Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into the vast unlit spaces between stars, into the gentle hum of the universe itself, where silence is never truly silent and emptiness is never truly empty. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into the emptiness of the universe together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. If you close your eyes for a moment, imagine the faint blue glow of our planet slowly fading into black. The chatter of radios, the flicker of city lights, the thin hush of the atmosphere, all fallen away behind you. Above the last shimmer of clouds, there's only the soft hum of machinery and the long breath of silence waiting beyond. Somewhere between Earth and eternity, a handful of small messengers continue their lonely flight. The Voyagers, the Pioneers, the New Horizons probe, each carrying a small piece of us into the dark. They are not fast by cosmic standards, but they are steady, patient, relentless, moving through a sea so vast that even the word vast feels too small. Voyager 1, our farthest traveller, now drifts more than 23 billion kilometres from home, so distant that its radio signal takes nearly a whole day to reach us. A single, quiet beam of energy stretching across the dark like a whisper between worlds. Its twin, Voyager 2, moves on a slightly different path, heading toward a faint red star called Ross 248. In the language of human time, it will not arrive there for another 300,000 years. By then, our languages may have changed beyond recognition, and the memory of these small ships may exist only as dust on the pages of history. Far behind them trail their older siblings, Pioneer 10 and Pioneer 11, the first to cross the invisible line we call the solar system's edge. They no longer speak. Their voices faded decades ago, their last signals faint as candlelight in a storm, yet they keep moving, silently, faithfully, obeying the simple laws of motion that need no audience. To drift forever is still a kind of purpose. The youngest of these wanderers, New Horizons, once swept past Pluto, that icy outpost of sunlight, and sent home a picture of a heart-shaped plain of frozen nitrogen. It now travels through the Kuiper Belt, that ring of icy remnants where the sun's warmth barely reaches. Its tiny generator still glows faintly, but one day even that warmth will fade. There will be no more power to send messages, no spark left to turn its antenna toward home. When that happens, it will become a perfect symbol of what we are: small, curious, and willing to send our questions into the dark, even when no one answers back. Each of these spacecraft carries a story etched in metal and memory. The Voyagers bear a golden record, a time capsule of sound and image, a child's laugh, a mother's kiss, the heartbeat of the earth, the murmur of rain, and greetings spoken in dozens of languages. It's strange and beautiful, isn't it? To imagine that somewhere, in a future we will never see, another intelligence might stumble upon it and listen. Perhaps they will not understand the words, but they may sense the warmth in the voices, the rhythm of breathing, the tone of belonging. Because even across unimaginable distances, emotion is still a kind of universal language. You might wonder why we did it. Why send fragile machines into an infinite night? The simple answer is curiosity. But there's something gentler beneath that. Maybe we just wanted to know if the silence could be broken, if somewhere the universe might whisper back. When we talk about the emptiness of space, what we really mean is the absence of what feels familiar. There is no air to carry sound, no breeze to stir dust, no horizon to rest the eyes. Yet emptiness itself is a kind of presence. Between the stars lies an ocean of particles thinner than any vacuum we can make on Earth, but they are still there. Hydrogen, helium, cosmic dust, drifting, colliding, carrying faint electric murmurs from ancient explosions. It's comforting in a way to know that even in silence something remains. Our probes travel through that quiet sea like small boats gliding across an endless calm. Their radio signals, though fading, still ripple outward at the speed of light. One day those ripples will reach another star, and much later, perhaps, another civilization. The message will be faint, but it will say something simple. We were here. The universe doesn't rush. It has all the time there is. For a beam of a light to cross from one side of the galaxy to the other takes 100,000 years. Our fastest ships would need tens of thousands of human lifetimes to do the same. And yet, the journey has already begun. Humanity's first fingerprints now rest on the interstellar wind. When Voyager 1 crossed the heliopause, the border where the sun's influence gives way to the wider galaxy, it entered what scientists call interstellar space. But perhaps that phrase is too cold. It didn't enter emptiness. It entered the quiet between heartbeats, the place where the pulse of one star ends and another's begins. As you breathe now, you might imagine that the air in your lungs once came from such distant places. Recycled stardust, atoms blown out from supernova millions of years ago. The same elements that light our cities once burned in suns long dead. Even the spacecraft drifting into the dark are made of the same cosmic matter that once glowed in stellar hearts. In that sense, nothing ever truly leaves the universe. It only changes its rhythm. So, as you listen to the soft hum of your room, picture those tiny ships sailing through an ocean of black, carrying songs, laughter, and light from a small blue world. Out there, where the sun is just another point among billions, they continue their silent testimony to human wonder. And somewhere, across that infinite quiet, the universe listens, not with ears, but with time itself. If we follow the trail a little further, the story of those distant travellers begins to feel less like science and more like a quiet meditation on time itself. They are not ships in any ordinary sense. They carry no passengers, no fresh air, no voices echoing through metal corridors. They are simply machines, and yet they are something more. Extensions of our own imagination, our wish to keep moving even when everything else must rest. Picture one of them now, a speck of metal adrift against the background of 1 billion stars. It turns slowly, keeping its fragile antenna pointed toward the tiny dot of sunlight it once knew as home. Each faint pulse of radio energy that leaves its dish travels outward at the speed of the light, 300,000 kilometers per second, and even so, it takes more than 20 hours for the message to cross the distance back to Earth. When that signal finally arrives, it is weaker than the glow of a watch battery seen from the other side of the world. But our great dishes listen, patiently decoding those delicate ripples into data, into images, into proof that we are still connected to something impossibly far away. Voyager 1 was launched in 1977. For a while, it was simply one of many spacecraft, circling planets, capturing portraits of Jupiter's storms and Saturn's rings. But when it crossed the outer boundary of the Sun's magnetic field, the heliopause, it became the first human-made object to touch the interstellar ocean. There was no line drawn across space to mark the border, only a gradual fading of the solar wind, a subtle change in the rhythm of particles. To our instruments, it was a scientific measurement. To the imagination, it was a passing of the torch from one realm to another, from the warmth of the sun to the cold patience of the galaxy, Its twin, Voyager 2, followed a different route, taking a grand tour through all 4 giant planets. It saw the blue marble of Neptune, the pale rings of Uranus, the intricate storms that swirl endlessly in alien skies. When it too left the Sun's domain, its instruments kept recording faint vibrations, tiny impacts from dust grains, whispers of magnetic fields. Every bit of that information had to cross the emptiness like a message in a bottle. And even now, somewhere beyond the outer dark, the spacecraft still sends a heartbeat, a slow series of data tones repeating every few seconds saying, "I am here." Behind them, the pioneers travel on, older and quieter. Pioneer 10, the first to slip past Jupiter, last spoke to us in 2003. Pioneer 11 went silent even earlier, its final signal fading into the noise of space like the last echo in a cathedral. Yet both carry plaques, small metal greetings etched with diagrams of our solar system and the figures of a man and a woman. The choice to send those images was both scientific and tender. It says to whoever might find them, this is who we were. This is what we looked like when we first learned to reach beyond ourselves. Then there is New Horizons, launched in 2006, still young compared to its predecessors. It was built with better eyes, a sharper mind, and the calm determination to photograph a world that for decades had been nothing but a blur in telescopes. When it flew past Pluto in 2015, the dwarf planet revealed itself not as a frozen wasteland, but as a landscape carved with mountains of ice and plains shaped like a heart. For the first time, we saw sunlight reflecting off a place that had never been visited by life, and for a moment, it felt as if distance itself had softened, like a curtain pulled aside just enough for us to glimpse another kind of beauty. Now, New Horizons drifts through the Kuiper Belt, where ancient fragments circle in slow, silent orbits. Out there, the sun is no longer a blazing disk, but a bright star among countless others. The probe's small nuclear generator still provides warmth, but each year its power fades. Someday the signal will stop, as all signals do, but the spacecraft will continue to sail on, unhearing, unwatched, its trajectory unbroken for millions of years. Long after Earth's continents have shifted, long after our cities have turned to dust, it will still be travelling, proof that curiosity can outlive its makers. If you listen closely, you can almost imagine their paths as a kind of symphony. Each probe plays its own note, moving through space at a steady tempo. The pioneers mark the opening chords, the Voyagers carry the melody outward, and New Horizons lingers on the final refrain. Together they form a composition measured not in minutes or hours, but in centuries. When the music ends, it will not be silence, because the universe itself hums beneath everything. A faint background of microwaves left over from the first light, the breath of creation still resonating after 13 billion years. Sometimes scientists joke that space is mostly empty, but that word mostly hides a world of subtlety. Between the planets, the vacuum is thin but not perfect. There are stray atoms drifting, mostly hydrogen, sometimes helium, occasionally a grain of dust born from a dying star. Each atom has its own story, its own momentum, its own quiet dance. When a spacecraft moves through that sea, it leaves an invisible wake, disturbing particles so few and far between that you could travel for a lifetime before meeting another. It's tempting to think of this as lonely, but perhaps it's more accurate to call it peaceful. In the emptiness, nothing rushes, nothing decays quickly. Even the faintest signal can travel undisturbed for billions of years. Somewhere far in the future, the last radio whisper from Voyager 1 will keep moving, weaker and weaker, but still coherent, still a fingerprint of our existence. It will not fade completely until it meets the thin gas between galaxies and merges with the background murmur of the cosmos. And maybe that's the quiet miracle hidden in these machines. They remind us that to be small is not to be insignificant. They prove that even a speck of metal launched from a tiny world can find a path through infinity. When you think about it that way, each of us is a kind of voyager too, made of atoms that once belonged to stars, carrying our own stories through the void, radiating our small warmth into a universe that listens in its own patient way. As we drift further into the story, the focus will shift from these fragile creations to the landscape they inhabit. The space between the stars, the gentle pulse of light from our nearest neighbours, and the strange comfort of knowing that even emptiness has structure. For now, let the thought settle. The messengers are still out there, moving through the dark, and their journey is also ours. The path now carries us toward the edge where light itself begins to thin, where the faint electric heartbeat of our ship slows and the warmth they carry begins to fade. Power out there is more precious than gold. Each spacecraft depends on the slow decay of a small chunk of radioactive material, quietly releasing heat that is converted into electricity. It's called a radioisotope thermoelectric generator, but you can imagine it more simply as a candle that never truly burns, but glows a little less with every passing year. Voyager 1's power comes from 3 such candles. When it left Earth, they glowed bright enough to run all its instruments, heaters and transmitters. But each year the warmth dims by about 4%. What began as a steady hum of energy is now just enough to keep a few of its vital senses alive, a magnetometer to feel the invisible currents around it, a plasma detector to listen to the music of charged particles. Engineers back home have shut down one system after another, choosing carefully which parts of the craft to let fall silent so that others may whisper longer. It's a bit like living in a house during a long winter and deciding which rooms to keep warm and which to close. The day will come when even that warmth runs out. The nuclear material, a rare isotope of plutonium, will continue to decay for centuries, but the energy it releases will no longer be enough to power the instruments or the radio. The spacecraft will grow cold, its electronics frozen, its antenna deaf. And yet it will not stop moving. Momentum will carry it forward through interstellar night at nearly 17 kilometers per second, about 60,000 kilometers each hour, a pace that would circle Earth in under an hour, but barely nudges the cosmic distance between stars. The math sounds grand, but the image is humbler, a grain of dust sliding across an endless table. When the signal stops, there will be no drama, no final flash or farewell. The great antennas on Earth will simply listen one day and hear nothing. The silence will not announce itself. It will just be there, a quiet absence in the background of static. For a while, the scientists who have worked on these missions will keep checking, hoping for a flicker. Then eventually the listening stations will turn their attention elsewhere. The probes will keep sailing on, blind and mute, but still loyal to their trajectories, obeying the same laws that govern planets and stars alike. You can almost picture it. In the black ocean of space, a small craft gliding through the last traces of sunlight, its power fading like an ember in deep water. Behind it, the Milky Way arches overhead, a pale river of starlight so vast that even imagination falters. Each of those stars is a sun in its own right, surrounded by worlds we have yet to see, and between them lies more space than we could ever fill, thin, cold, silent, but not truly empty. It's filled with the faint breath of hydrogen atoms, 1 or 2 in every cubic meter, enough to carry the memory of creation but too few to touch. The idea of a vacuum might make you think of nothingness, a complete absence. But in truth, even the most perfect vacuum hums with invisible energy. It's full of ghostly fields that shimmer and cancel, a restless background of potential. When a spacecraft moves through that sea, it disturbs those fields ever so slightly, leaving ripples that no one can measure but that still exist. The emptiness responds. It always has. In the quiet, we start to notice time in a different way. On Earth, we measure it by the turning of the planet or the ticking of clocks. Out there, time flows with the fading of power, with the cooling of metal, with the distance a signal travels before it grows too weak to hear. The speed of light becomes a kind of hourglass. For every billion kilometers a message travels, there's another delay of almost an hour. The further the spacecraft drifts, the older its words become by the time we hear them. When we listen to Voyager now, we're hearing what it said more than 20 hours ago, the past arriving slowly across the dark. Imagine standing on a hill at night, watching a thunderstorm far away. You see the lightning flash, but the sound takes longer to arrive, rolling across the fields like a deep exhale. The further away the storm, the longer the silence before the thunder. That's what it's like to talk to a spacecraft beyond the sun's reach. The silence stretches until the delay itself becomes part of the conversation. And yet, in that silence, something profound happens. We begin to feel not just distance, but connection. A thread stretched thin but unbroken. The faint power left in those ships is the last bridge between two kinds of isolation, ours and the universe's. As long as the probes still send their faint signals, they remind us that emptiness can be crossed, that even fragile voices can survive in the dark. On Earth, we are surrounded by abundance. Heat, light, sound, the constant rush of life. Out there, every watt of power, every gram of energy is sacred. It takes light more than 4 years to reach even the nearest star, and the space in between is almost unimaginably barren. But somehow, we've learned to persist. We've built machines that can keep a heartbeat going through the cold for decades, powered by the slow glow of atoms falling apart. Maybe that's what the universe respects most: persistence. Stars burn, collapse, and rise again as new stars. Planets freeze, thaw, and find balance. Even the smallest photon, once released, travels on forever unless it meets another atom. Everything continues not because it must, but because motion itself seems to be the universe's way of remembering. If you ever find yourself wondering what becomes of those tiny vessels once they go quiet, imagine this. Somewhere, in the darkness between constellations, the Voyagers and Pioneers drift together in spirit, though their paths never truly cross. Their antennas face different directions, their metal skins cooled to the temperature of interstellar night, about 3 degrees above absolute zero, just a whisper of warmth left from the beginning of time. They do not see or speak, but they share the same endless horizon. In that sense, they are not lost. They are simply continuing like echoes that refuse to fade. And so, our quiet exploration continues. The ships have carried us as far as our machines can go, and their lights are fading at the edge of the sun's domain. But beyond that faint horizon lies something grander, the region between stars where new journeys begin and the true emptiness reveals its hidden architecture. The trail of our curiosity leads us there next, into the interstellar medium, where the dust of old stars meets the promise of new ones, and silence begins to shimmer with possibility. From here, the story opens into the question that lingers at the heart of every space dream. How do we keep going once the fire runs out? The ancient engines that carried our probes are little more than stored explosions, brilliant but brief. They burn, push, and fade. Every kilometre they travel is bought with the release of chemical energy, and though it sounds mighty, the truth is that even our most powerful rockets are humble when measured against the scale of the stars. The great Saturn V that once carried humans to the moon would need more than 100,000 years to reach the nearest star, and that's if it could burn forever. Fire simply isn't enough when the night is infinite. The first lessons in space travel teach humility. To leave Earth's gravity requires tremendous force. To keep travelling beyond the pull of the sun demands something rarer still: endurance. Our rockets flare like matches in the dark, then drift silently for decades, coasting on the inertia that Newton described centuries ago. Motion continues not because the engine still burns, but because nothing is there to slow it. The vacuum of space offers no friction, no wind, no resistance. Once you start moving, you simply keep going, forever, unless another force intervenes. It's comforting in a way. The universe obeys its promises. Over the years, we've tried to find new ways to push farther. Ion engines hum instead of roar, trading speed for stamina. They work by releasing charged atoms, ions, at immense velocity, one after another, like a soft but endless breeze. Each puff adds a whisper of motion, and together, over months and years, they build up to speeds that chemical rockets could never reach. If traditional engines are like sprinting, ion propulsion is like walking forever without tiring. The spacecraft Dawn, which visited the asteroid belt, used such an engine to travel nearly 7 billion kilometers with only a small tank of xenon gas. You could hold the fuel in your hands, yet it carried a machine across the void. Then there is the dream of sunlight itself. Imagine using the pressure of light, those tiny photons that never rest, to sail through space as ancient mariners once sailed on wind. A solar sail is nothing more than a sheet of reflective material, so thin that it could tear under your breath. Yet in the vacuum, every particle of light that strikes it gives a nudge. Over time, those nudges accumulate. With no drag to slow it down, a sail pushed by sunlight could one day reach the edges of our planetary system without ever burning a drop of fuel. The poetry of it is irresistible. To move by light alone, to travel because the universe shines. But even light can be slow when your destination lies across the centuries. The nearest star system, Alpha Centauri, sits more than 40 trillion kilometers away. Light itself, the universe's fastest traveler, takes over 4 years to reach it. At that scale, distance becomes less a measure of space and more a measure of time. Every meter between stars is a moment stretching outward. To travel there by conventional means would take tens of thousands of lifetimes, far beyond the endurance of any machine or memory. That is why new ideas keep flickering at the edges of science, dreams half mathematical, half poetic. The Breakthrough Starshot project, for instance, imagines sending thousands of miniature probes no bigger than coins, each attached to a sail thinner than paper. From Earth, a vast array of lasers would shine upon them, pushing them with beams of pure light until they reached a fraction of light's own speed. At that pace, they could cross the Gulf to Proxima Centauri in just 20 years. They would arrive as tiny sparks, no larger than dragonflies, but carrying cameras and sensors small enough to send back glimpses of alien worlds. Whether such technology will work is still uncertain, but the vision itself feels like an echo of humanity's oldest instinct, to explore not for conquest, but for connection. Beyond that, there are whispers of even stranger possibilities. Warp drives that curve space instead of crossing it, fields that stretch the fabric of reality so that a ship might slide forward while space itself moves around it. Physicists call this the Alcubierre concept, after the man who imagined it. It remains firmly in the realm of theory, because to bend space in this way would require more energy than any star can provide, and perhaps the creation of matter with negative mass, something we've never observed. Still, the image endures, a bubble moving through the universe like a drop of rain gliding across glass. Science may not know how to build it, but the idea reminds us that curiosity itself can reshape our boundaries. And then there's the vacuum, that word again, misleading in its simplicity. In the stillness between stars, the so-called empty space isn't truly empty at all. Quantum physics tells us that it quivers with energy, that tiny pairs of particles appear and vanish every instant, like bubbles rising and popping in an invisible sea. Some scientists call it zero-point energy, the faint residue that remains even when everything else is removed. A few dream that one day we might tap into that background hum, turning the fabric of space into a source of motion. Others suspect that trying to do so would change the nature of reality itself. Either way, it speaks to a truth that feels ancient. Even the void is alive with potential. When you think about it, propulsion, the art of moving through nothing, is really about patience. It asks us to accept that progress can be slow and still meaningful. The pioneers, voyagers, and New Horizons drift because we gave them a small push and trusted physics to do the rest. In a sense, every orbit, every comet, every photon is propelled by that same faith. The universe has no engine. It simply expands quietly, carrying everything with it. Galaxies drift apart not because they're running, but because space itself is stretching beneath them. Perhaps that's the lesson hidden inside the mathematics. Movement is built into existence. We don't need to fight the emptiness. We only need to join its rhythm. Our ships teach us that a single impulse, a burst of light, a flicker of heat, can send something moving for eternity. The rest is waiting, listening, and remembering that time and distance are just two faces of the same quiet truth. So as you imagine the Voyagers still sailing, picture them now as leaves caught on a gentle cosmic tide, no longer powered by flame, no longer guided by control, yet perfectly content to drift. Around them, the darkness isn't a wall but an ocean, full of unseen currents soft with the pressure of light. And somewhere in that slow motion, the story of motion itself begins to blur into something deeper. The beginning of the interstellar sea, where stars are no longer distant beacons but part of a silent, connected whole. That is where we'll go next, to trace the faint glow of our nearest neighbours and feel what it means to live among stars that never sleep. As we drift further into the story, the darkness begins to shimmer again, faint, scattered and patient. One by one, the stars return. To the human eye, they look close, like bright grains of salt scattered on velvet. But between each of those sparks stretches a gulf so wide that even light, travelling faster than anything we can imagine, needs years to cross it. Our sun's closest companions are not a few hours away, not even a few decades at the speed of our ships. They are more than 40 trillion kilometres from home, and yet, in cosmic terms, they are our neighbours. The nearest of them, Alpha Centauri, is not a single star but a small family, a trinity bound together by gravity and history. Two of them, Alpha Centauri A and B, are golden suns, circling one another in a slow and elegant dance that takes about 80 years to complete. The third, a faint red ember called Proxima Centauri, drifts farther out, completing its long orbit in silence, more than 400 times the distance between Earth and our Sun. If you could stand on an imaginary world orbiting Proxima, the night sky would be both familiar and strange. The two larger suns of Alpha A and B would shine as brilliant twin stars, not as distant points, but as beacons bright enough to cast shadows. The rest of the heavens would look much as they do from Earth, a reminder that even when you move to the edge of another system, you're still part of the same grand tapestry. Proxima Centauri itself is smaller and cooler than our Sun, burning with a deep crimson hue. Its light is soft but deceptive. Flares can erupt without warning, flooding nearby space with bursts of radiation. For that reason, the little planet that circles it, known as Proxima b, may be both hospitable and hostile at once. It orbits close enough to receive warmth. Its year lasts only about 11 of our days. But that closeness means it is likely locked by gravity, showing one face always toward its star, while the other remains in endless night. On the day side, the red sun might hang eternally above the horizon. On the night side, starlight would glimmer over frozen oceans. Between those extremes, perhaps there could exist a twilight belt, a narrow ribbon where temperatures soften and winds carry warmth between the light and the dark. If life could ever learn to adapt to perpetual dawn, that's where it might thrive. Further out, another possible planet, Proxima, circles its star at a distance far colder than Earth's orbit. It may be wrapped in ice and methane, or it may not exist at all. The truth still waits in data we can barely read, flickers of brightness that rise and fall as the planet's gravity tugs at its star. Every detection is a whisper, every confirmation a small victory. Astronomy often works like that, not with shouting discovery, but with careful listening. The brighter pair, Alpha Centauri A and B, offer their own potential worlds. Around Alpha A, scientists once detected a signal that looked like a planet, then doubted it, then saw it again. Perhaps it was a mirage of noise, or perhaps it was a real world circling just inside the star's habitable zone, a place where liquid water might shimmer under yellow light similar to our own. Alpha B, slightly cooler, might host smaller rocky companions. We don't know yet, but every year, new instruments sharpen their gaze, peeling away the glare of the stars to look for the faint dimming that might betray an orbiting planet. It's humbling to realise how close and how far this system truly is. At our current speeds, even the fastest human-made object, Voyager 1, moving at about 17 kilometres each second, would need more than 70,000 years to reach the Centauri stars. 70,000 years. Entire civilizations could rise and fall in that time. Languages would fade, continents shift, memories dissolve. Yet we still speak of it as if it were a destination, as if patience could be measured in millennia. That too is a kind of faith. The Alpha Centauri system, if seen from afar, would show our sun as just another point in its sky, faint, yellow, and unremarkable. From there, we would be the distant ones, orbiting an unseen star that flickers faintly among billions. It's an elegant symmetry. Each world looks out and thinks of itself as the centre, while the universe quietly smiles and says, "You are all centres, and all equally small." There's something soothing about that thought. The emptiness between here and there isn't hostile, it's simply vast. If you could compress that distance into something tangible, it would be like stretching a thread of light across a silent ocean. Along that thread drift dust grains, tiny atoms, and maybe, someday, our own probes sailing by on beams of laser light. Projects like Breakthrough Starshot imagine sending them. Miniature messengers that could cross the gulf in a human lifetime, propelled by the pressure of photons. Should that dream succeed, the first images of another sun might reach us before the end of this century. A sunrise from 40 trillion kilometres away. A message not just from another world, but from our own persistence. And yet, even as we imagine those journeys, we can look up tonight and see Alpha Centauri with the naked eye, glowing softly near the horizon if you live in the southern hemisphere. That light left those stars over 4 years ago, long before this moment, long before whatever you are thinking now. To see them is to see the past, preserved and delivered by the most patient courier in the universe, light itself. Every star we look at is a time capsule, each photon a traveller that has crossed unimaginable distance to touch our eyes. We are quite literally bathed in ancient light. If the emptiness between us feels intimidating, remember that it also connects us. The same space that separates us from Alpha Centauri is filled with the same quiet particles that once flowed from our own sun. The vacuum is not a wall. It's a bridge woven from the fabric of time. Somewhere out there, Proxima's red glow and our yellow sunlight mingle, their waves passing through each other, their energy blending into a single harmony that neither star will ever hear. In the calm of this moment, that thought feels almost like a lullaby. Distance does not erase connection, it only softens it. The nearest stars remind us that emptiness is full of motion, of light, of memory. Every spark in the sky is an answer to a question we didn't know we were asking. Is there anyone else? The universe replies in its quiet way. Not yet, perhaps, but keep listening. And so we will. Our quiet exploration now turns toward the other lights nearby, the ancient wanderers and the restless suns that share our corner of the galaxy. for among them lie stories of time, of survival, and of the delicate balance between warmth and solitude. The trail of clues leads us gently into a deeper part of our neighbourhood, a quiet realm filled with familiar yet distant lights, each carrying its own rhythm, its own fragile orbit through time. When you look at the night sky, most of what you see are young and confident suns, burning bright and fast. But hidden among them are the elders, the wanderers, and the odd companions, stars that have seen the galaxy turn many times over. One of the most remarkable among them is Barnard's star. It's so faint that you can't see it without a telescope, yet astronomers know it as one of our closest neighbours, only about 6 light years away. What makes it special is not its brightness, but its motion. Against the backdrop of distant stars, Barnard's star slides slowly across the sky, moving faster than any other visible star. Each century it shifts by the width of half a full moon, a gentle reminder that even the heavens are not still. It's an ancient red dwarf, nearly twice as old as the sun, and it burns with a soft crimson of endurance. Its energy is steady but dim, a candle that could burn for trillions of years while brighter stars come and go. Around it orbits a world known as Barnard's star B, or at least we think it does. The evidence is delicate, tiny wobbles in the star's light, almost like a pulse beneath a fingertip. If the signals are true, that planet is a frozen super-Earth, about 3 times the size of our own, where the surface might glisten with ice under a dim red glow. Imagine standing there, where midday is as dark as an earthly sunset, and the star never rises higher than a pale ember on the horizon. The wind would whisper across plains of frozen methane, and the only warmth would come from the heart of the planet itself. Yet, in its quiet coldness, it would still be a place of motion, a world circling faithfully around a tiny sun, proof that life, even impossibility, adapts to every kind of silence. A little farther across the void lies a far brighter story. Sirius, the dog star. It's the most luminous star in Earth's night sky, bright enough to shimmer through thin clouds or even catch your eye in daylight if you know where to look. The ancient Egyptians built temples aligned with its rising, believing it heralded the flood of the Nile and the renewal of life. To early mariners it was a compass in the dark. But behind that brilliant light lies a secret. Sirius is not 1 star but 2. The first, Sirius A, is the blazing beacon we see, twice as massive as our sun and far hotter, shining white-blue like an electric flame. The second, Sirius B, is its ghostly companion, a white dwarf, the collapsed remnant of a star that burned out long ago. Though it's roughly the size of Earth, it carries almost the same mass as the Sun, which means its matter is squeezed to a density that defies imagination. A teaspoon of Sirius B's substance would weigh as much as an entire mountain. Yet even that extreme has a gentle poetry to it, a reminder that what once burned brightly can still persist in a quieter form. The 2 stars orbit each other every 50 years, their paths looping in a cosmic waltz, the living and the remnant forever entwined. Far from this blazing duo lies another cluster of promise, the Wolf 1061 system. Its star is another red dwarf, smaller and cooler than the Sun, but circled by 3 rocky planets, and one of them rests in the so-called habitable zone, where temperatures might allow liquid water to exist. Astronomers have nicknamed it Wolf 1061c, though names can feel too mechanical for something so romantic. Think of it instead as a quiet refuge in a red twilight. If you could stand on its surface, you might see the star looming huge and orange in the sky, its dim light spreading warmth like a dying hearth. The days would be long, perhaps lasting weeks, the seasons subtle but patient. It's unlikely that we'll ever visit it in person, but just knowing it exists makes the emptiness around us feel a little less lonely. The truth about red dwarfs like Barnard's and Wolf 1061 is that they are not rare. They are the universe's favourite kind of star. For every bright sun like ours, there are dozens of these small, steady lanterns scattered through the galaxy. They live far longer than stars like the Sun, quietly burning hydrogen for hundreds of billions of years. When all the great blue giants and yellow suns have faded, the universe will still be lit by the soft crimson of red dwarfs, the candlelight of eternity. It's possible that life, if it ever endures that long, will find its home beneath those dusky skies. It's humbling to think that stars so faint to our eyes could be so abundant that the galaxy's true colour, if you could see it from afar, might be not golden but red. Every one of those tiny suns is a possible world, a potential home. The space between them feels endless, yet when you begin to see how many there are, you realise the emptiness is stitched together with light. And there are others nearby, each with its own peculiar charm. Lalande Texasuchikijewon 85, another red dwarf, sits just a few light years beyond Wolf 1061. It may host planets too, perhaps rocky, perhaps not. Captain Star, an old traveller likely born in another galaxy, now passes quietly through our neighbourhood, carrying with it planets that formed in a place long since torn apart. Even our solar system once brushed close to other stars. One ancient encounter may have tilted our planetary orbits ever so slightly, a small ripple in the long history of cosmic meetings. When you pause to consider it, all these systems, Barnard's, Sirius, Wolf, 1061, form more than just a list of names. They are waypoints in the great silence, markers of how far our imagination has travelled. Each tells a different story about how stars live and age, how worlds might orbit quietly for eons, how light continues even after fire fades. Together they paint a picture of our local space not as empty, but as alive with rhythm and variety. As you lie there listening, you might imagine the faint light from those stars brushing against your skin, light that began its journey years ago, crossing the same cosmic sea our probes now wander. The atoms in your body, the air you breathe, the warmth you feel, all of it comes from such stars. You are, in every literal sense, made of them. Perhaps that's why the sight of a star can make us feel both small and deeply at home. From here, the story will drift outward again, beyond our neighbourhood of familiar suns, into the wider currents of space where even starlight grows thin. There, the sun itself becomes just one flicker among billions, and the space between those flickers reveals its own secret architecture, a web of matter and emptiness, gravity and light, holding the universe together in perfect silent tension. If we follow the thread a little further, the story begins to dissolve into something harder to see. The airless ocean that surrounds every star, the silent substance between the lights. It may sound strange to speak of air in space, yet the region our sun drifts through has its own texture, its own subtle weather, woven from atoms and magnetic fields. It is called the local interstellar cloud, and it is our home in the greater sea. Imagine, for a moment, that the solar system is a tiny boat moving through a vast, transparent fog. That fog is unimaginably thin, so thin that a cubic metre of it contains only a few atoms, fewer than you'd find in the smallest breath of air, and yet it is enough to define a place. The local cloud is warm, about 7,000 degrees Celsius, but so rarefied that you would not feel its heat even if you could touch it. The particles are too far apart to pass warmth from one to another. It's like a ghost of a gas, a lingering whisper of old explosions. Our sun entered this region a few tens of thousands of years ago, just a blink in cosmic time, and one day it will leave again. Beyond it lies another zone, the G cloud, and beyond that a larger cavity called the local bubble. That bubble is a great hollow in the galactic disk about 1,000 light years across, and its walls are made of denser, cooler gas. Inside it, space is almost empty, swept clean long ago by a series of supernovae. dying stars that released waves of energy powerful enough to carve out a cosmic cavern. You might picture those ancient explosions as the soundless thunder that shaped our sky before the Earth even formed. Each supernova sent shockwaves rippling outward, clearing the surrounding gas, lighting up space with bursts of radiation that travelled across the Milky Way. What's left behind is the bubble we now inhabit, a region of rarefied gas laced with magnetic fields and dust, glowing faintly in ultraviolet light. Our entire solar system, planets and all, floats inside this immense hollow, like a dust mote inside a cathedral dome. It's a beautiful thought, isn't it? To realise that even emptiness has boundaries, that even the void can have walls. The stars nearest to us, Alpha Centauri, Sirius, Procyon, all rest on the edge of this bubble, their stellar winds merging with ours, shaping invisible currents of plasma. Where these flows meet, they form a soft frontier, a place where the energy of one system brushes against the next. These boundaries are not solid, but fluid, alive and constantly shifting, like tides in a cosmic sea. The Voyager probes were the first to cross our solar system's smaller bubble, the heliosphere, and taste the medium beyond. There, the solar wind fades, replaced by the interstellar breeze. It carries traces of oxygen, nitrogen, and dust, atoms born in stars that lived and died long before our sun was born. When those atoms drift into the heliosphere, some are caught by the sun's magnetic field, slowed and heated until they glow faintly in ultraviolet light. We've even detected a gentle wind of interstellar helium sweeping through the solar system at about 25 kilometers each second, fast enough to circle Earth in less than 30 minutes. But numbers alone don't capture its grace. You could think of it as the sigh of the galaxy itself, a steady breath that moves through the scattered rooms of space. Every planet, every comet, even the faint trail of meteors that streak through our atmosphere, all are shaped in some way by that distant breath. The local cloud shields us from harsher radiation, filters the starlight that reaches us, and adds its faint dust to the tapestry of zodiacal light you sometimes see as a soft glow near the horizon after sunset. It's easy to forget that we are part of it, carried along in its current. If you could look upon this region from afar, you'd see a patchwork of bubbles, not unlike soap films touching and merging, each created by the life and death of stars. Some are still expanding, others collapsing. Our local bubble connects to others, forming tunnels through which particles and light flow. In a sense, the Milky Way breathes through these structures. Its stars exhale matter in supernovae, and that material later condenses into new stars, new planets, and new possibilities for life. Destruction and creation are not opposites here. They are the same motions seen at different moments. The atoms drifting past us tonight may once have belonged to a star that died near the constellation of Scorpius. Its light reached Earth 10,000 years ago. Its dust only arrives now. In that dust are traces of iron, carbon, and silicon, the same ingredients that form the rocks beneath your feet. Some of it will fall into our atmosphere, mingle with rain, and settle into the soil. A handful of those particles may one day become part of a living cell or part of a thought. Even across the emptiness, the galaxy continues to share its substance. When scientists map the magnetic fields within the local bubble, they find that its walls bend and twist like invisible silk ribbons. The field lines guide cosmic rays, funneling charged particles through narrow paths. Occasionally these paths cross Earth, sparking tiny showers of high-energy particles that flash for an instant in the upper atmosphere. To most of us they are invisible, but to detectors in orbit they are a kind of heartbeat, proof that the universe is not still, that the vacuum itself is alive with motion. All this happens in silence, yet the silence is not empty. It is full of relationships, between stars, between dust and wind, between past and future. The space between worlds is not a void to be feared, but a bridge that connects every glowing point in the sky. Even the thin air of the local cloud carries memory. The ashes of long-dead stars, the magnetic traces of ancient storms, the promise of new creation waiting quietly to unfold. When you look up tonight, remember that the space between the stars is not nothing. It is the soft fabric through which everything is threaded, us, our sun, and the faint dust that carries our story. We are passengers in a moving sea, part of a vast current that began long before we existed and will continue long after we're gone. From here, the story carries us deeper still, past the boundaries of the bubble and into the realm of the wanderers, the worlds that drift without suns, untethered yet not forgotten. There, in the loneliest reaches of space, we find planets without stars and stars that have lost their worlds, all suspended in the same gentle darkness that carries us forward. The path now carries us into a quieter realm, one that feels lonelier than anything we have yet imagined, a place where worlds exist without stars, where night never ends, and where light itself is only a memory. These are the rogue planets, the wanderers of the galaxy. They travel not in orbits but on straight, endless paths, drifting through the dark like seeds blown from a broken branch. For most of history, we assumed every planet belonged to a star, that worlds were always part of a family circling a source of warmth and gravity. But the universe has a way of bending our expectations. In the last few decades, astronomers began to find clues, faint distortions of starlight, sudden flickers that hinted at invisible travellers passing between us and distant suns. Those clues revealed what had once been unthinkable. Billions of planets may roam freely through space, unattached to any star. For every world like Earth, there could be 2 or 3 that wander alone. Some of these planets were likely born in the usual way, inside the swirling disks of newborn stars, but were later cast out by the violence of their youth. When multiple worlds grow close together, gravity becomes a dangerous game. A passing giant can sling a smaller planet outward, like a stone skipping off water, sending it beyond the reach of its sun forever. Others may have formed alone in the cold collapse of dust clouds that never grew massive enough to ignite into starlight. Whether cast out or never chosen, they drift on, invisible to almost every telescope. One of the most haunting examples lies not far from us in cosmic terms, a faint, frigid world known as WISE 08550714. It's about 7 light-years away, practically a neighbour compared to most stars, yet it gives off no visible light. We found it only because it glows faintly in the infrared, the colour of gentle heat. Its temperature is roughly 20 degrees below freezing, not unlike a winter night on Earth. Clouds of water ice swirl through its atmosphere, forming frozen weather under a permanent midnight. It may be a planet, it may be a failed star called a brown dwarf. In truth, the line between the two is as thin as frost. What matters more is what it represents. The idea that a world can exist in perfect darkness and still have shape, still have presence. Astronomers have found other candidates too, bodies with masses similar to Jupiter or Saturn drifting through the Milky Way. Some were discovered through an effect called gravitational microlensing, a phenomenon predicted by Einstein long before we had the tools to observe it. When a massive object passes in front of a distant star, its gravity bends the star's light, magnifying it for a brief moment. By measuring the timing of that brightening, scientists can infer the size and mass of the unseen traveller. It's a method that requires patience and luck. The alignment must be almost perfect. Yet it has already revealed dozens of lonely planets, each one a silent echo moving across the galactic background. To find more, researchers are planning new missions, some already being built, others still on paper. One of them, charmingly named Cleopatra, We'll use artificial intelligence to sift through millions of microlensing events, searching for the faintest hints of free-floating worlds. Another, the Nancy Grace Roman Telescope, will look for them with eyes sharp enough to see planets smaller than Mars hiding in the dark. Within the next decade, we may know just how many of these drifters share our galaxy. Not a handful, but perhaps hundreds of billions. If you try to picture such a world, it's tempting to imagine only the cold and the dark, but there is more subtlety there. Many rogue planets, especially the large ones, may still carry warmth deep inside, the heat left over from their formation, or from the slow decay of radioactive elements in their cores. Some could have atmospheres thick enough to trap that warmth, or oceans sealed beneath crusts of ice, never touched by starlight yet gently warmed from below. On Earth, we've found life thriving near volcanic vents at the bottom of the sea, where sunlight never reaches and the only energy comes from the planet itself. If life can survive there, perhaps it can survive in the vast night too, not basking in sunlight, but drawing from the steady heartbeat of a planet that refuses to freeze. The thought of such hidden life feels both eerie and comforting. Imagine a world where the sky never brightens, where the only illumination comes from the faint shimmer of auroras rippling through an atmosphere rich in methane and hydrogen. The air would glow softly near the poles, painted by magnetic fields that twist like invisible brushstrokes. Beneath that sky, mountains of black ice might rise above frozen plains, and deep below them, a liquid ocean could murmur against stone. If there were creatures there, they would never know stars. Only the slow pulse of their planet's own heat, the rhythm of tides born from memory rather than moonlight. To live in such a place would mean redefining what it means to have a home. Without sunrise or sunset, time itself would lose its usual pattern. Days and nights would merge into one long, silent flow. Perhaps life would adapt by measuring change in other ways, by the cycle of geothermal surges, by the whisper of shifting ice, by the faint pulse of chemical energy passing from one cell to another. Even here, in what we once thought of as nothingness, the universe would find a way to keep time. Rogue planets remind us that belonging is not always about attachment. They are solitary, yet not abandoned, cold, yet not lifeless. They drift through the Milky Way with quiet dignity, part of a migration older than stars. Some will eventually be captured by new suns, circling fresh centres of light. Others will wander forever, their orbits carrying them between spiral arms, through the thin gas of interstellar space and into the shadows beyond. But each, in its own way, proves that motion does not need purpose to be beautiful. If you close your eyes now, you might imagine one of them passing beneath your gaze, a faint sphere moving silently across the black. No sunlight to mark its path, no comet tail, no reflection, only gravity guiding its way. Somewhere on its surface, frozen, clouds swirl in silence, sculpted by winds that have never seen a horizon. It moves without destination, but not without grace. In a universe where everything spins and collides and fades, such calm persistence feels like its own kind of miracle. And as we drift further through this story, our gaze begins to shift again, from the planets that wander alone to the hearts that anchor everything else. For in the vast emptiness between stars, gravity still holds dominion. It gathers dust and gas, it shapes galaxies, and it gives birth to the most mysterious entities we know. The black holes, those sleeping giants that swallow light itself. Beyond the solitary worlds lies a deeper kind of silence, one with gravity so strong it bends both time and meaning. That is where our next quiet step will lead. From here, the story opens into the deepest silence of all, a place where even light hesitates, where space itself folds inward like fabric drawn to a single thread. You've heard the name before, a black hole. Yet the words themselves hardly capture the strange peace of what it truly is. It is not a hole in the sense of emptiness, and it is not black in the way that shadows are. It is a region where gravity becomes so intense that it bends the very shape of reality. Space curves inward, time slows, and light, that fastest traveller of all, can only circle, unable to escape. Imagine a vast plane of space as a soft sheet of cloth. Now place a heavy sphere upon it. The fabric bends, creating a gentle bowl. This is how gravity shapes space. A planet makes a shallow dent, a star a deeper one. But a black hole presses so hard that it tears through, creating a funnel so deep that nothing can climb out. The point where this funnel begins, where light can no longer find its way back, is called the event horizon, the boundary of goodbye. It is not a surface you could touch. It is simply the place where all paths turn inward. The heart of a black hole is called the singularity, though the word is more poetry than science. It is a place where our equations stop working, where the concepts we use to describe the universe lose their meaning. Density, time, volume, all become tangled together. No one knows what truly happens inside. It could be a point smaller than an atom, or a hidden doorway into another realm of space-time. Some theories even suggest that the singularity might never form at all, that nature hides it behind the horizon, as if protecting us from knowing too much. Black holes are born from collapse, from endings that are not really endings. When a massive star exhausts its fuel, its own weight turns against it. The outward push of fusion ceases and gravity takes control, compressing the star's core with unstoppable force. If the star is heavy enough, more than 3 times the mass of our Sun, it will collapse completely, its matter crushed beyond measure. In that instant, a black hole is born. What was once a bright, burning sun becomes an invisible well of gravity. One such remnant, known as A0620, lies in the constellation of Monoceros. It is about 3,000 light-years away, not far by galactic standards, and it formed when a star many times larger than the Sun died in a spectacular collapse. We cannot see it directly, but we can watch its companion star, which circles the darkness like a moth around a flame. The black hole feeds from it, pulling a thin stream of gas that swirls into a glowing disk. That disk, heated to millions of degrees, shines in X-rays before the matter finally falls inward and disappears from sight. Even in darkness there is radiance, the last light before surrender. And then there is the giant at the centre of our own galaxy, Sagittarius A star. It sits 30,000 light-years away, hidden behind clouds of dust and gas, invisible in ordinary light. Yet with radio telescopes we can see the stars that dance around it, moving at incredible speeds, some completing their orbits in little more than a decade. One of them, known simply as S62, approaches the black hole closer than any other known star. At its nearest, it travels at about 8,000 kilometers each second, fast enough to cross the distance from Earth to the Moon in less than a minute. And yet it survives, held in a perfect balance between motion and gravity. It is proof that even near the darkest hearts, order can exist. We might imagine a black hole as an engine of destruction, but it is more accurate to see it as a sculptor. Its gravity shapes the orbits of stars, organizes galaxies, and gives rhythm to the cosmic dance. Without black holes, the universe might lack the structure we take for granted. The space around them is not chaotic, but astonishingly precise. The closer you move toward the event horizon, the more space stretches and time dilates, as if the universe itself were whispering, "Slow down, look closely." If you were to fall towards such a horizon, gently, without panic, you would not notice the moment of crossing. From your point of view, everything would seem smooth, even ordinary. The curvature of space would stretch your path, and distant light would grow redder, fainter, until it vanished completely. To an outside observer, your fall would appear to slow endlessly, frozen in time. You would become part of the horizon itself, a memory suspended forever at the edge of visibility. time and perspective part ways at the boundary of goodbye. There's a certain quiet elegance in that. A black hole is not the enemy of light, it is its archive. Every photon that touches the horizon adds to its mass, and in doing so, the black hole becomes a kind of record, not of destruction, but of absorption. Even the darkest places hold the memory of what they've taken in. In a sense, nothing is truly lost. It is simply stored in a form we cannot yet decipher. Some physicists even suspect that information, the most delicate fabric of reality, may remain encoded on the horizon, like a hologram written on space itself. If true, it means that every black hole is both an end and an archive, a cosmic library written in gravity's alphabet. The universe, it seems, has a fondness for paradoxes. The most powerful voids are also the greatest preservers. The darkest places are full of the most intense energy, and the regions where time slows most are the very engines that keep galaxies alive. Around black holes, space and time trade roles. Motion becomes stillness, stillness becomes motion. The closer we look, the more the borders blur. If you listen carefully, you might almost hear the idea humming beneath all this. The sound of inevitability, but also of balance. Without collapse, there can be no creation. Without darkness, light would have nothing to define it. Black holes remind us that even the universe needs contrast, that gravity itself is a kind of music, one that plays in a key too deep for us to hear. And as our journey continues, we will find that even these invisible hearts have companions. Stars, disks, even planets may orbit them at safe distances, dancing in the glow of light that never escapes. There, in the company of darkness, we discover that not even the most extreme void stands alone. As we drift further into the story, the silence around black holes begins to reveal its texture. It's tempting to imagine these objects as solitary, isolated points that devour everything and leave only emptiness behind. But even in this most extreme of realms, companionship persists. Black holes have partners. They attract, they orbit, they feed, and they sculpt the space around them into shapes that can be both terrifying and beautiful. What we call darkness is not absence. It's a stage where light performs its most dramatic dance. Picture a small black hole and a star caught in its gravity, a pair bound together by invisible threads. The star continues to shine, unaware that its outer layers are being gently pulled away, stretched into a spiral that wraps around the unseen partner. The gas it loses forms a disk, an enormous whirlpool glowing with heat as it falls inward. The closer the gas gets, the faster it spins, heating until it shines in X-rays. Light too energetic for human eyes, but visible to instruments that orbit Earth. In these faint, flickering signals, we witness the quiet hunger of gravity itself. To the eye of imagination, this is no violent act, but a kind of waltz. The star and the black hole circle one another with steady rhythm, trading matter for motion, light for stability. The physics is complex, but the feeling is simple. Balance. The black hole cannot swallow the star all at once. It feeds slowly, letting gravity and motion hold everything in perfect tension. From a distance, it's a scene of serenity. A glowing ring surrounding darkness, both sustained by their mutual pull. In some systems, two black holes orbit together, locked in an endless embrace. They spiral closer over billions of years, radiating energy as ripples in space-time, gravitational waves that spread outward at the speed of light. When they finally merge, the energy released is staggering, for a moment outshining all the stars in the visible universe. Yet even this cataclysm is quiet in its own way. No flash, no explosion, just a single pulse of distortion. The universe itself trembling for a heartbeat before settling again. We have only recently learned to listen for that faint vibration, detecting it with instruments sensitive enough to measure changes smaller than the width of an atom. The universe speaks in whispers, and we're just beginning to understand its language. Quasars are another kind of companion story, the brightest lighthouses powered by the darkest engines. At the centre of young galaxies, supermassive black holes feed on torrents of gas and dust. As that material spirals inward, friction and gravity heat it until it glows brighter than 1,000,000,000,000 suns. From across billions of light years, we can see that glow, sometimes flickering, sometimes steady, marking the place where a galaxy's heart beats fastest. To human eyes, a quasar looks like a star, a single point of light. But in truth, it is a galaxy shouting softly across eternity. The beam we see tonight may have begun its journey when Earth was still a world of oceans and microbes. Every photon carries a story from the past, born near a horizon where time nearly stopped. Closer to home, the same process unfolds in miniature. In binary systems like A0620, the feeding black hole releases jets of energy, thin streams of particles moving at nearly the speed of light. These jets shoot into space in opposite directions like the breath of some invisible dragon. They pierce through surrounding gas clouds, shaping nebulae and sometimes even triggering new waves of star formation. Out of the darkness, new light emerges. It's a reminder that black holes are not destroyers. They are participants in the ongoing cycle of creation. Not all of their companions are luminous. Some may be planets, faint frozen worlds orbiting far enough to avoid destruction. A few simulations suggest that entire systems could exist around black holes, their nights illuminated not by sunlight, but by the eerie glow of the accretion disk. On such a world, day and night would blend into perpetual twilight, and the sky would shimmer with arcs of blue and gold light curving around the black hole's gravity. A person standing there might see their own shadow bending upward, their reflection duplicated and stretched by space itself. The physics would be strange, but the view, indescribable. Even black holes that have stopped feeding, their disks long gone, still interact with their surroundings. Their gravity shepherds stars into new patterns, sending some spinning into the galactic core while flinging others outward at enormous speeds. The fastest star ever observed, travelling at over 6,000 kilometres each second, owes its motion to such a close encounter. It was once part of a pair that wandered too near Sagittarius A star. The black hole captured one star and slingshot the other outward, giving it enough momentum to escape the galaxy altogether. That lone star now races through intergalactic space, destined to drift forever between galaxies, a solitary ember thrown from a cosmic fire. And then there is the faintest whisper of all, Hawking radiation. It's a theory that says even black holes, the most perfect absorbers, are not entirely silent. Quantum physics predicts that pairs of virtual particles constantly appear and vanish in empty space. Near a black hole's horizon, one of these particles can fall in while the other escapes. The result is a slow leakage of energy, a whisper of light escaping eternity. Over unimaginable spans of time, the black hole would fade, growing smaller, cooler and fainter, until it simply disappears. For the smallest black holes, this process might take a mere fraction of a second. For the giants at galactic centres, it would take longer than the current age of the universe multiplied countless times. But even in that theoretical end, the tone remains gentle. Nothing erupts, nothing breaks. The black hole simply exhales the last of its borrowed energy, leaving behind silence. It's a humbling vision. The most powerful forces in the cosmos turn out to be governed by patience, not fury. They do not roar, they hum, they do not consume, they transform. Around them, galaxies organize, matter circulates, light bends into new shapes. And always the same rule holds: gravity binding motion to stillness, darkness to light. If you listen closely, you can almost hear it. The slow rhythm of space breathing, the deep heartbeat of the universe. It's not the sound of destruction, but of balance. Even in the company of darkness, there is harmony, a balance so perfect that it creates beauty we can barely comprehend. As we drift onward, our gaze will widen again, from single black holes and their partners to the grand pattern they help weave. The Milky Way itself, our home, is one such pattern, a spiral of light spinning quietly around a dark heart. In its structure lies the same lesson we've carried all along, that emptiness and weight, light and darkness, chaos and order, are never opposites. They're companions too, always orbiting one another, always creating something worth looking at. The path now carries us home, or at least to the vast structure that has always been our home, though we've seen only fragments of it. Every night when you look up and see that pale, misty river crossing the sky, you're seeing just one thin edge of our galaxy, the Milky Way, a spiral of light that stretches for more than 100,000 light-years across, its arms curving gracefully through the dark. For all our telescopes and equations, we still live inside it like fish trying to map the ocean from beneath the waves. If we could step back and see it from afar, the Milky Way would look like a luminous pinwheel suspended in black. Its arms would gleam with billions of stars, rivers of gold and blue curving around a bright centre. That centre, though hidden by clouds of dust, is where a great bulge of old stars gathers, surrounding the quiet giant we already met, Sagittarius A*, the supermassive black hole that anchors everything. Around it spin hundreds of millions of suns, each following a path shaped by gravity and time. Our sun lives far from that crowded heart, out on a quiet lane called the Orion Arm, a minor spur of one of the galaxy's main spirals. It's a calm neighbourhood, not too dense, not too empty. Astronomers sometimes call this region the galactic habitable zone, a gentle belt where radiation is moderate and star formation is steady. Too close to the centre, and supernovae erupt too often, stripping away atmospheres. Too far out, and there isn't enough heavy material to build planets at all. We are, it seems, in a perfect middle distance, not by design, but by chance. It's a reminder that balance, even in the cosmos, often comes quietly. Within this structure, every element has its role. The central bulge is like the galaxy's beating heart, dense with ancient suns that have burned for billions of years. Around it extends a flat disk, where newer stars like our Sun live, born from the dust and gas recycled by generations of dying ones. Beyond the disk lies the halo, a vast dim sphere containing old star clusters and the mysterious substance we call dark matter. Though invisible, dark matter outweighs everything we can see. It acts as the unseen skeleton of the galaxy, shaping its rotation, keeping the stars from flying apart. Without it, the Milky Way would unravel, its arms scattering into intergalactic night. Between those arms lies the Great Rift, a dark band that cuts across the Milky Way's bright lane in the sky. It looks like an absence of stars, but it's not empty at all. It's a curtain of dust, thick clouds of carbon and silicate grains that block visible light, hiding the stars beyond. Through infrared eyes, we can see that the Great Rift is rich with star-forming regions, nurseries where gravity is slowly gathering gas into new suns. What seems like darkness is really potential, light that has not yet learned to shine. If we trace the motion of our stars, we find that they do not simply circle the centre, but oscillate up and down, weaving through the galactic plane like a slow tide. The sun itself bobs gently, rising and falling above and below the disk every few tens of millions of years. We're midway through one of those cycles now, sailing upward through the plane of the galaxy at about 7 kilometers each second, fast enough to cross the Atlantic Ocean in less than a minute. Yet we feel nothing, because everything around us, the planets, the comets, even the empty air, moves with us. Our galaxy's story is one of constant evolution. It's not a single structure frozen in time, but a living city built from mergers and collisions. Billions of years ago, the Milky Way swallowed smaller galaxies, their stars mixing into its halo like memories folded into a dream. One of the most significant of those mergers was with a system known as Gaia Enceladus, an ancient galaxy that collided with ours roughly 10 billion years ago. The evidence of that event remains in the motions of certain stars which travel on elongated orbits different from the rest, like ghosts moving through a crowd. They are the ancestors of our galactic body, the bones of what came before. Without them, the Milky Way would not be what it is today. Everywhere we look, that same pattern repeats, old giving way to new, chaos resolving into form. Star clusters dissolve, scattering their children into the disk. Gas clouds collapse and ignite. Supernovae explode, seeding the interstellar medium with heavy elements, carbon, oxygen, iron, that later condense into planets, oceans, and life. The galaxy breathes in cycles of death and rebirth. It is both graveyard and nursery, both memory and possibility. Sometimes, when you see the Milky Way stretched across a summer night, it's easy to forget that what you're looking at is light from the past. The faint glow you see now may have left its star thousands of years ago. The centre of the galaxy, that bright hub hidden behind the Great Rift, shines with light that began its journey 26,000 years before we were born. In a way, the sky is not a window, but a time machine. Every shimmer above us is history, still arriving. We like to think of our galaxy as stable, but it too is in motion. The Milky Way is drifting through space toward the Andromeda Galaxy at roughly 400 kilometers each second. The two are on a slow, inevitable collision course that will take about 4 billion years to complete. When they meet, their stars will rarely collide directly. The distances are too vast, but their shapes will twist and merge, forming long tidal streams of starlight that will eventually settle into a single, larger galaxy. It's an act of cosmic transformation so slow that, from our perspective, it will seem like a gentle unfolding, not an impact. And yet, even knowing this, there's comfort in the scale. The Milky Way has existed for nearly 14 billion years and will continue to exist for trillions more. Its arms will keep spinning, its heart will keep glowing, and new stars will keep being born long after we're gone. To stand beneath its light is to share for a brief moment in that endurance. If the earlier parts of our journey have been about silence and isolation, this one is about belonging, about seeing ourselves as threads in a vast luminous tapestry. The galaxy is not just where we live, it is what we are made from. Every atom in your body, every breath you take, was once part of a star that lived and died within these same arms. You are the Milky Way thinking about itself for a fleeting second in the long rhythm of time, and as our quiet voyage continues, our attention turns outward once more, beyond the edges of our own spiral, across the darkness that separates us from our nearest galactic neighbour. There, far beyond the Great Rift and the halo's faint shimmer, another great city of stars waits for its moment to meet us. Its name is Andromeda, and its story is already written in our future. From here, the story opens outward once again. We drift past the familiar arms of the Milky Way and into the quiet between galaxies, where gravity stretches thin and stars become sparse. The distances grow so enormous that numbers lose their meaning. What once seemed infinite, the space between Earth and the Sun, or even between our stars, now feels like the small ripples on a much greater ocean. Out here, the Milky Way is no longer a home. It is a single island of light in a vast archipelago of galaxies. And across this silent gulf, about 2.5 million light-years away, another island shines, the Andromeda Galaxy. To the naked eye, it looks like a faint blurred smudge in the night sky, so soft you might mistake it for a small cloud. But through a telescope, it unfurls into a luminous spiral, its arms stretching across 200,000 light-years, twice as wide as our own. It contains nearly 1 trillion stars, suns like ours, each with its own worlds, its own histories, its own silent observers perhaps looking back. For now, Andromeda seems peacefully distant, gliding through the void at a stately pace. But appearances can deceive. In truth, our two galaxies are rushing toward each other at about 400 kilometers each second. A collision in slow motion, an embrace that will unfold over the next 4 billion years. If you were to speed up time, you would see them dance, their spiral arms reaching toward each other, twisting and stretching until they merge into a single, larger galaxy. Astronomers sometimes call this future creation Milkomeda, a new shape born from two long-lived companions finally meeting after a lifetime apart. This may sound violent, but it will not be. The space between stars is so vast that most will pass one another unharmed. Instead, gravity will rearrange them like dancers changing partners, blending the two systems into one seamless form. Clouds of gas will collide and ignite in waves of starbirth, painting the merged galaxy with newborn light. Even in destruction, creation endures. If any descendants of humanity are still watching then, they might look up at the night sky and see not a Milky Way, band, but a sweeping oval of stars, the signature of a union millions of years in the making. Andromeda, like our own galaxy, has its hidden stories. At its heart lies a double nucleus, two bright points of light orbiting each other so closely that they blur into one. One of them may conceal a supermassive black hole even larger than Sagittarius A star, feeding quietly on surrounding matter. Near that core, astronomers have found a peculiar blue giant known as AE Andromeda, a luminous, unstable star whose brightness swells and fades like the breathing of a great creature. In human terms, it lives fast and briefly, its life measured in only a few million years. To the galaxy, it's a flicker, a heartbeat. Long ago, in the year 1885, another heartbeat flared brighter than any star. A supernova, the explosive death of a massive sun, lit up Andromeda's core, briefly visible even through the haze of its distance. It was the first such event ever recorded beyond our galaxy, a hint that the universe contained more than we had imagined. The astronomer who discovered it, Ernst Hartwig, could not have known that he was watching the echo of a collapse so vast it released more energy in 1 week than our sun will emit in its entire lifetime. That light travelled for over 2 million years before it reached his telescope, a message from the deep past arriving right on time. Andromeda's story is not one of perfection, but of persistence. Like our Milky Way, it has devoured smaller galaxies over the eons, their remnants visible as faint streams of stars arcing through its halo. One of its former companions, now called M32, is a compact elliptical galaxy, stripped of its outer layers by Andromeda's gravity, a remnant of collision, a survivor in miniature. Another, M110, orbits it still, like a small moon circling a vast world. Within Andromeda's disk lies NGC 206, a brilliant star-forming region, a nursery glowing with blue and white clusters, each containing hundreds of massive young suns. If you could stand there, within one of its new systems, the night would never be dark. The sky would blaze with thousands of nearby stars, their light reflecting off dust clouds and casting a pale shimmer across every surface. When we look at Andromeda through telescopes today, we're seeing it as it was 2.5 million years ago, around the time when the first ancestors of humankind walked upright on the African plains. The light that reaches us tonight left long before our species existed, before written language, before fire, and yet, here it is, touching our eyes. The galaxies are so far apart that their conversation takes millions of years for each exchange, but the message never stops. Gravity does the talking now, slow and inevitable. The pull between our galaxies is already written into their motion, as if the universe itself remembers that everything that drifts apart will someday drift together again. In the grand scale of the cosmos, collisions like this are common. The universe builds its structures through these graceful destructions, merging small galaxies into large ones, weaving stars into new shapes. Even our Milky Way, serene as it seems, bears the scars of its past. Ghostly streams of stars that once belonged to other systems, now folded into our own. In the darkness between these great collisions, isolated galaxies float like lanterns, untouched for billions of years. Some spin alone in the void, their nearest neighbours tens of millions of light years away. They are the true recluses of the cosmos, brilliant but solitary, shining for no one but themselves. When Andromeda and the Milky Way finally merge, their black holes will spiral together at the centre, orbiting faster and faster until they unite. The gravitational waves from that final moment will ripple across the universe, faint but eternal, carrying the signature of two galaxies becoming one. Long after the last stars have cooled and faded, those waves will still be moving outward, the final heartbeat of a once bright cosmos. It's strange, isn't it? To think that even on these unimaginable scales, the universe still follows patterns of union and separation, of approach and retreat. The galaxies move toward each other not with urgency, but with inevitability, like tides drawn together by a hidden moon. Their meeting will erase the familiar constellations, but it will also create new ones. The sky our distant descendants see will be different, but no less beautiful, another page in the same endless story. And so, as our gaze lingers on Andromeda, that faint blur in the night, we can think of it not as a stranger, but as a relative. It is our sister galaxy, born from the same ancient matter, following the same laws, dreaming the same dream of light. And one day, far beyond the reach of human time, we will share the same horizon. Two rivers of stars will join, and the darkness between them will no longer divide, but embrace. If we follow the thread a little further, beyond the Milky Way and Andromeda, beyond the familiar glow of clustered stars, the pattern of the universe begins to change. From a distance great enough that even galaxies shrink to glittering dots, a new kind of beauty appears, one that only becomes visible when you stop looking for individual lights and start seeing the spaces between them. The universe, it turns out, is not scattered randomly like sand thrown into the dark. It is woven. Imagine a vast lace stretched across infinity, a delicate web of filaments and voids, each strand made of countless galaxies strung together by invisible gravity. This is the large-scale structure of the cosmos, the architecture of everything that exists. It is both chaotic and precise, as though the universe was spun from threads of light and shadow by some quiet hand of physics. Astronomers first began to glimpse this pattern when they mapped the positions of thousands of galaxies. What they expected to find was a smooth, even distribution. Instead, the data revealed clumps and filaments, long chains of galaxies stretching for hundreds of millions of light years, separated by enormous empty regions. The universe on its grandest scale looks astonishingly like something organic. The branching of neurons, the veins of a leaf, the roots of a tree seen through clear water. The same geometry repeats at every level, from the swirl of hurricanes to the spiral of galaxies to the invisible web that holds them all together. What binds this structure is gravity, but not gravity alone. There is also something unseen, dark matter, the quiet architect behind the scenes. Though invisible, it outweighs ordinary matter by nearly 5 to 1. We know it is there not because we can see it, but because of how it bends light and sculpts motion. When galaxies spin faster than they should, when clusters remain bound when their visible mass is too small, dark matter is the hidden thread that explains it. You might think of it as scaffolding made of gravity, a silent skeleton that gives shape to everything luminous. Scientists believe the cosmic web began as the faintest ripples in the early universe, small fluctuations in density, only 1 part in 100,000. Over billions of years, those tiny differences grew. Gravity pulled matter into denser regions, while dark energy stretched space itself, creating the great contrasts we see today. Galaxies formed along the densest filaments like beads on invisible strings, while the gaps between them expanded into immense voids. To describe the scale is almost impossible. The largest filaments can span over 1 billion light-years, distances so vast that light, moving at nearly 300,000 kilometers each second, would take 100 million years to cross them. Within these strands, clusters of galaxies gather like dewdrops, each containing trillions of suns. The spaces between, the voids, are not truly empty, but so thin that an entire galaxy might drift there and never meet another for eternity. If you could somehow stand outside the universe and look back upon it, you would see something that looks strangely familiar. A glowing network stretching in all directions, filaments of gold and violet light fading into darkness. And if you zoomed in close enough, you might notice that each node of brightness is a galaxy cluster, and within each galaxy, billions of stars, and around each star, perhaps worlds, and on at least one of those worlds, us. Small minds trying to understand the pattern we're woven into. When scientists simulate this structure on supercomputers, they often say it looks alive. The filaments twist and grow, merging and branching like living tissue. It's as though the universe itself is a great organism, with galaxies as its cells and dark matter as its connective tissue. There's no centre, no edge, only an intricate balance of attraction and expansion, gravity and emptiness. The result is something profoundly peaceful, an infinite network, quietly breathing. The idea that we live inside a web changes how we see everything else. We're not floating in isolation, but suspended in connection. Every galaxy, every cluster, even the space between them contributes to the balance. Light travels along the filaments, bending slightly as it passes through gravitational fields. When we study the faint distortions in distant starlight, a phenomenon called gravitational lensing, we can trace the unseen strands of dark matter itself. In this way, even the invisible becomes visible, not through direct sight, but through the way it guides what can be seen. In the past few years, telescopes like the Sloan Digital Sky Survey and the Dark Energy Spectroscopic Instrument have mapped millions of galaxies across billions of light years, turning data into a 3-dimensional atlas of the universe. When those maps are visualized, they resemble vast coral reefs, glowing in slow motion. Filaments connected by bright knots, each one a supercluster of galaxies. The images are not just scientific, they are profoundly artistic, reminders that knowledge and beauty are not opposites, but reflections of the same curiosity. You might wonder where our galaxy sits in all this. The Milky Way, along with Andromeda and dozens of smaller companions, is part of the Local Group, a cluster about 10 million light-years across. That group sits within a larger structure known as the Local Sheet, which in turn lies on the edge of the Virgo supercluster. And that supercluster itself is part of an even greater structure, the Laniakea supercluster, a vast region over 500 million light-years wide, whose name means immeasurable heaven. It is our continent in space, a gathering of galaxies all flowing along gravitational currents toward a mysterious region called the Great Attractor. Even here, language begins to fail us. The scale is so immense that it defies both imagination and metaphor, and yet in a quiet way it feels familiar. Every thread, every cluster, every glowing node is connected, not unlike the connections in the human brain, where 100 billion neurons form a similar pattern of filaments and nodes. Perhaps that is why, when we look at the maps of the universe, they feel almost intimate. They look like thought itself, as if the cosmos were reflecting on its own existence. In this grand design, there is no absolute center, no privileged point of view. Every observer, wherever they stand, sees the same universe expanding away from them. The web stretches in all directions, and from every place within it, the pattern remains true. It's a kind of quiet democracy of perspective, a reminder that in the larger sense, everything is equally small and equally part of something immeasurable. And so, as we trace these filaments across the dark, we begin to understand that the universe is not a collection of separate things, but a single, continuous story. Every atom, every star, every stretch of empty space contributes to that story, woven together by gravity and time. What we call emptiness is really just the canvas on which connection is drawn. From here, our path drifts toward the deeper silences, the spaces between these filaments, the cosmic deserts so wide that entire galaxies could be lost inside them. These are the voids, the calm centers of nothingness where even light seems reluctant to travel, and it's there, in that quiet, that the universe's most mysterious kind of beauty waits. The trail of our journey now leads us away from the glowing threads of the cosmic web and into the open spaces between them, the vast deserts of the universe. Here, light grows thin, galaxies become rare, and silence stretches farther than imagination. These are the great voids, the hollows of creation, so wide that a beam of light could travel for hundreds of millions of years and never meet a single star. To step into one, even in thought, is to understand what true emptiness means, and to realize that even emptiness is not truly empty. Imagine drifting through such a region. Around you there is no up or down, no sense of motion, only the faint background hum of starlight arriving from incomprehensible distances. The nearest galaxy might lie 100 million light-years away. To put that gently, if you travelled at the speed of the light itself, the fastest anything can move, you would still need 100 million years to reach your first neighbour. And yet, even here, space is not pure nothingness. It contains the thinnest of gases, perhaps a few atoms in every cubic metre, as well as dark matter, the invisible skeleton of the cosmos stretching silently beneath it all. One of these empty expanses lies remarkably close to us, a region astronomers call the local void. It begins just beyond the edges of our galactic neighbourhood and extends for more than 200 million light-years, a yawning gulf with almost no galaxies inside. The Milky Way, it turns out, sits right on its border, like a small town at the edge of a vast uninhabited plain. Beyond that plain lies another cluster of galaxies, the Virgo supercluster, but between the two stretches a nearly unbroken darkness. The local void may have influenced the very motion of our galaxy, pulling it gently toward brighter regions as though urging us away from its quiet interior. Farther out, hidden behind veils of dust, lies the Taurus void, an even greater emptiness that occupies a portion of sky in the direction of the constellation Taurus. For decades it remained mysterious because interstellar dust in the plane of our own galaxy blocked our view. Only through radio telescopes could astronomers begin to trace its edges. It appears to be immense, perhaps 600 million light-years across, though the numbers matter less than the feeling. A cosmic ocean so deep that an entire cluster of galaxies could sink inside it and never be seen again. And then there is the KBC void, named for the 3 scientists who proposed its existence. It is among the largest structures ever detected, a region nearly 2 billion light-years wide, so sparse that it may stretch across a measurable fraction of the observable universe. Some researchers think this giant hollow could help explain a long-standing cosmic puzzle: why different methods of measuring the universe's expansion give slightly different answers. If our galaxy happens to sit near the edge of such a vast underdense region, the local expansion rate, the speed at which space itself grows, might appear faster than average. In this way, even emptiness exerts influence. Nothing, it seems, still shapes everything. Within these voids, Galaxies are rare but not entirely absent. Some drift alone, far from any cluster, their spiral arms unperturbed for billions of years. One such outpost is NGC 64503, often called the Lonely Galaxy. It resides at the edge of the local void, isolated from its peers, suspended in a region of space almost completely devoid of other systems. And yet, it shines. It continues to form new stars, its spiral arms curling gracefully through silence. It is proof that even isolation can harbour creation. The idea of nothingness can sound bleak, but these voids are far from dead. They expand with the universe itself, their boundaries stretching as space grows. Within them, the faint gas left behind after the Big Bang continues to thin, cooling over billions of years. Each atom inside drifts freely, rarely colliding with another, yet across unimaginable time, even these rarefied atoms shape the future. Gravity from the surrounding filaments tugs gently on the void's interior, causing matter to migrate toward denser regions. The emptiness grows emptier, while the bright regions grow brighter. A slow sculpting of contrast that defines the large-scale pattern of the cosmos. To visualize it, imagine the universe breathing. With each cosmic breath, the bright filaments tighten and the voids exhale, expanding outward. It's not a violent motion, but a graceful one. A balancing act between gravity, which pulls matter inward, and dark energy, which drives the expansion of space. Together they create a rhythm that has shaped everything since the dawn of time. From a philosophical view, the voids invite reflection. They remind us that the absence of matter does not mean the absence of meaning. In fact, it is the emptiness that allows form to exist. Without space between the stars, their light would never travel. Without the silence between sounds, music would lose its rhythm. In that sense, the great voids are not failures of creation, but its framework. The blank canvas on which the galaxies can paint their luminous patterns. Even light behaves differently here. In dense regions, gravity curves its path, bending it around massive clusters. But in the voids, space-time relaxes and light travels almost perfectly straight, unhindered by matter. It's as if the universe rests here, taking a long, slow breath between the bright chapters of its story. Astronomers studying these regions find that cosmic microwave background radiation, the faint afterglow of the Big Bang, passes through voids with subtle distortions, like ripples moving through still water. These distortions tell us not only about the structure of the voids themselves, but about the unseen energy that drives the universe to expand faster and faster. You could think of the voids as nature's pauses, the silent intervals between verses in a cosmic song. They offer balance to the symphony of galaxies, just as darkness balances light. And they are growing. As the universe expands, the voids stretch wider and the luminous filaments thin out. Billions of years from now, many galaxies will drift beyond each other's reach, their light redshifted until it fades from view. The night sky will become quieter, lonelier. Yet within that solitude lies a strange peace, the calm of a universe still unfolding, still breathing, even in silence. The thought may sound melancholy, but it also carries a quiet hope. For as long as emptiness exists, so too does the potential for new creation. The hydrogen drifting through these voids may one day gather again, perhaps in another age, forming new galaxies, new stars and new worlds. Nothing, it turns out, is never truly nothing. The universe, even when still, is always in motion, a patient artist sculpting with the faintest tools of time and gravity. As we move forward in our journey, we'll begin to see how even this emptiness connects, how these voids, these pockets of quiet, are bordered by immense walls of galaxies and light. The universe may be expanding, but it is not unravelling. It is learning, slowly and elegantly, to breathe outward. As we drift beyond the cosmic deserts, where light is scarce and silence stretches unbroken, the universe begins to gather itself again. Out of the emptiness, structure returns. not as small galaxies or scattered clusters, but as immense walls of matter so vast they blur the line between physics and poetry. These are the frontiers of order, the continents of the cosmos, where billions of galaxies come together to form boundaries between nothing and something. Imagine flying above the universe as if it were a great ocean frozen in motion. Between the wide, dark hollows, bright ridges rise, filaments of galaxies forming colossal chains, looping and curving for hundreds of millions of light years. Each ridge is a wall of stars, a concentration of gravity so wide that light itself bends as it passes. Within those walls lie clusters upon clusters, each home to thousands of galaxies, and, within those galaxies, uncountable worlds. The scale is so enormous that if you could move at the speed of light, you would still need hundreds of millions of years to cross from one side to the other. Our own home, the Milky Way, sits within one of these immense structures. It belongs to a supercluster known as Laniakea, a Hawaiian word meaning immeasurable heaven. The name feels appropriate. Laniakea is not just a collection of galaxies, it is a landscape of gravity itself, more than 500 million light-years across. Within it flow cosmic rivers of motion, pathways shaped by the gravitational currents of neighbouring clusters. You can think of these galaxies not as static dots, but as leaves carried on invisible streams, all drifting toward a gentle centre of attraction. At the heart of that flow lies something mysterious, a region astronomers call the Great Attractor. It is not a single object, but a gravitational anomaly, a quiet whisper of mass drawing thousands of galaxies inward. Even our own local group, the Milky Way, Andromeda, and their smaller companions, is being pulled toward it, moving through space at roughly 600 kilometers each second. Yet we don't feel it. Gravity acts equally on everything, pulling the space we inhabit rather than the bodies within it. To us it feels like stillness, though we are gliding through the universe at unimaginable speed. The Great Attractor sits hidden behind dense clouds of our own galaxy's dust, in the direction of the constellations Norma and Triangulum Austral. Beyond it lies an even grander assembly, the Shapley concentration, a massive supercluster about 650 million light-years away, rich with galaxies and clusters, shining faintly like embers scattered across the dark. Together, these vast concentrations form part of a larger structure, a gravitational basin within which our entire region of the cosmos gently drifts. And yet, even this immense scale is only one step in the cosmic hierarchy. Far beyond Laniakea and the Great Attractor, astronomers have discovered structures that defy easy comprehension. One of them is the Hercules Corona Borealis Great Wall, a formation so large it seems to challenge the very age of the universe. It spans roughly 10 billion light-years from end to end, a distance so immense that the light from one side has been travelling toward us for nearly 3/4 of cosmic history. If the universe were a vast quilt, this wall would be one of its grandest stitches. How could such a structure exist? We're not entirely sure. Theoretically, gravity has not had enough time to knit together matter on that scale. Yet there it is, a ripple of brightness in the background of galaxies, a reminder that the cosmos still holds surprises beyond our models. Some scientists wonder whether what we call the Great Wall is not a single entity at all, but a chain of smaller structures that only appear connected from our point of view, like distant clouds blending at the horizon. Others suggest that perhaps our understanding of cosmic growth is incomplete, that matter may have found shortcuts we do not yet see, but perhaps the truest explanation is also the simplest. The universe has its own rhythm, one too slow and vast for us to grasp. What seems impossible may simply be what happens when time is measured not in years or centuries, but in the patient language of billions. If you could hover within the Great Wall itself, you would not feel any difference. Each galaxy would drift serenely in the dark, its suns burning quietly as they do here. The vastness hides itself well. Only from the outside, when viewed across the deep ages of light, does the pattern reveal its shape, clusters and filaments forming something that resembles the faint strokes of an artist's brush across an infinite canvas. In a way, these walls mark the edges of order, not in the sense of limits, but as boundaries where structure begins to dissolve into silence again. Beyond them, the universe returns to its deserts, to the wide and whispering voids. Matter and emptiness trade places in an endless rhythm, the dense becoming light, the light becoming empty, each giving meaning to the other. The pattern is not random. It is the quiet fingerprint of gravity at work, the same force that holds the moon in its orbit, shaping the entire architecture of space. When astronomers create maps of these walls, they often describe the result as hauntingly beautiful. Galaxies cluster along delicate arcs, forming tendrils that intersect at glowing nodes. Between them, dark voids stretch like calm lakes between mountain ridges. From far enough away, it looks less like a map and more like a heartbeat, peaks and troughs repeating, echoing the rise and fall of existence itself. It's tempting to feel small when confronted with such immensity, but there is another way to see it. Every atom in your body once belonged to that same network. The calcium in your bones, the iron in your blood, the oxygen in your lungs. All were forged in the hearts of stars that lie along these filaments. You're not separate from this cosmic architecture. You are built from it. The same gravity that shapes galaxies also shaped you, drawing matter together into consciousness, long enough to wonder at its own origin. As we look outward, the distances blur until the mind can no longer hold them, and silence becomes the only adequate language. The Great Walls are not boundaries to fear. They are reminders that the universe is not chaotic, but patterned, that even infinity has its hidden geometry. And somewhere beyond these walls, faint but steady, glows the oldest light of all, the first radiance from the birth of everything. It shines through the gaps and filaments alike, touching every corner of the universe with equal gentleness. The next step of our journey carries us toward that light, the afterglow of the first dawn, still whispering through space after nearly 14 billion years. From here, the story opens into the deepest memory of all, or the first light that ever existed, still drifting quietly through the universe like a long, unbroken sigh. It surrounds everything, filling every corner of space, yet it is too faint for our eyes to see. To human senses, it is invisible. To the universe, it is its oldest photograph. This is the cosmic microwave background, the afterglow of the first dawn. Imagine the universe when it was new, not the calm sky we know, but a blazing ocean of energy and particles, too dense for light to travel freely. It was only about 380,000 years old then, still a newborn in cosmic terms. In that age of fire, matter and radiation were tangled together in a storm of heat. Light could not move more than a few centimeters before scattering off electrons, like a sound lost in fog. But as the universe expanded, it cooled. The particles began to slow and combine, forming the first atoms, simple hydrogen and helium. And for the first time, space became transparent. Light was finally free to travel. That light, the first to roam unhindered, is what we still see today as the cosmic microwave background, or simply the CMB. Over nearly 14 billion years, the expansion of space has stretched its wavelengths from blinding white to soft microwave radiation, gentle, cold, and ancient. It fills the sky evenly, arriving from every direction, like the faint warmth that lingers in a room after a fire has gone out. Its temperature is about 2.7 degrees above absolute zero, only a whisper above complete stillness. Yet even in that near silence, it carries information about everything that would follow. When scientists first discovered this radiation in 1965, it was by accident. Two engineers, Arno Penzias and Robert Wilson, were testing a large radio antenna in New Jersey. no matter what they did, they kept hearing a persistent background hiss, a steady hum that seemed to come from every direction. They cleaned the antenna, recalibrated it, even shooed away nesting pigeons that had taken up residence inside the horn. But the signal remained. Eventually they realised what it was. The echo of the Big Bang itself, a faint murmur from the dawn of time, still whispering across the cosmos. Since then, that whisper has become one of the most carefully studied signals in all of science. Satellites like COBE, WMAP and Planck have mapped the CMB in exquisite detail, revealing tiny variations in its temperature, differences of just a few millionths of a degree. These variations, like soft ripples on a pond, mark the seeds from which all galaxies would later grow. Where the glow was slightly warmer, matter was denser. Where it was cooler, space expanded a little faster. Out of those microscopic imbalances, gravity began to sculpt the universe we know. Every star, every planet, every moment of beauty and chaos since then traces back to those first ripples in the ancient light. It is humbling to realise that perfection would have meant silence forever. If the early universe had been completely uniform, if its light were perfectly smooth, nothing could have clumped together. No stars, no worlds, no you, no me. The universe needed its small imperfections to become interesting. In its earliest light, it was already learning that even creation requires a bit of unevenness, a soft imbalance that makes growth possible. When we look at the cosmic microwave background today, we see it not with our eyes, but with instruments that translate microwaves into colour. The resulting maps resemble marbled patterns of blue, yellow and red, a portrait of temperature from an age when there were no stars. You can think of it as a baby picture of the universe, captured long before galaxies began to spin. Every swirl in that image is a memory of sound waves that once pulsed through the hot plasma of the early cosmos. Compressions and rarefactions, like the rise and fall of a cosmic heartbeat. In the middle of this faint glow lies a small anomaly, a patch of sky a little cooler than the rest. Astronomers call it the cold spot. It's not dramatic. The temperature difference is only about 70 millionths of a degree, but in a map of near-perfect smoothness, that small chill stands out. Some believe it marks a vast region of emptiness, a supervoid spanning billions of light years, where matter is thinner and space expands slightly faster. Others think it might be a statistical quirk, a coincidence born from random fluctuations. And there are those who wonder if it could be something deeper, a sign of contact between our universe and another, a bruise on the skin of creation where two realities brushed together long ago. No one knows for certain, but perhaps that mystery is part of its beauty. The cold spot reminds us that even the universe carries scars, faint irregularities that tell stories we're only beginning to imagine. The light that left that region has been travelling toward us for nearly 14 billion years. When it began its journey, there were no galaxies, no planets, no observers to notice it. And yet it travelled faithfully, crossing every epoch of cosmic history to reach us now, as we stand here, breathing under our small sky. If you close your eyes, you can almost feel it, that faint warmth touching your skin. It's everywhere, flowing through every room, passing through every body. The same photons that left the early universe have brushed against you countless times, threading through atoms and air, through the space between your hands. In a literal sense, you are wrapped in the light of the beginning. The first dawn never truly ended, it only dimmed as space grew vast. There's a strange comfort in knowing that the oldest thing in the universe is also the most democratic. It does not belong to any one place or time. Every planet, every galaxy, every being that has ever existed is bathed in it equally. It is the ultimate shared memory, the quiet proof that we are all woven from the same moment. As we drift onward, the light grows fainter, the frequency softer, until all that remains is the hum beneath silence, the restless vacuum itself still trembling with potential. For even when all visible light fades, space is never truly empty. Beneath the stillness lies motion. Beneath the quiet, a hidden pulse. Our next step leads us into that unseen realm, where even nothing is alive with possibility. From here, the story turns inward again, not towards stars or galaxies, but toward the spaces between them. It seems at first that there could be nothing left to find. The galaxies have faded behind us. The cosmic light has cooled into whispers. We have reached what appears to be pure emptiness, the quiet fabric that holds the universe together. And yet, even here, silence is only an illusion. The vacuum itself trembles. If you could somehow listen to that emptiness, not with your ears but with your imagination, you would hear a faint, constant vibration, the hum of existence that never truly stops. Physicists call this the quantum vacuum, though the phrase feels far too mechanical for something so subtle. You could think of it instead as a restless sea beneath stillness, a fabric so fine that reality itself is woven from its threads. Even when all matter and light are gone, this invisible ocean continues to ripple, filled with energy that never quite disappears. To understand this, imagine standing at the edge of a perfectly calm lake. The surface looks still, but beneath it, countless molecules move and collide, too small to see but always in motion. The quantum vacuum is like that. On scales smaller than atoms, space is never truly empty. Instead, particles appear and vanish in pairs, opposites born together and erase together. Like notes played so quickly they merge into silence. They exist only for a fleeting instant, shorter than any measure of time we can name, yet their effects can be felt everywhere. One of the most delicate proofs of this comes from an experiment known as the Casimir effect. Picture two metal plates placed a few micrometers apart, closer than the width of a human hair. Between them, something extraordinary happens. The vacuum's constant vibration is slightly reduced, because only waves that fit perfectly between the plates can exist there. Outside, all possible waves still ripple freely. The imbalance creates a tiny pressure, pushing the plates together as though the nothing between them were gently breathing. It's a minuscule force, but measurable, a reminder that even nothingness can move the world. The Casimir effect is not magic. It is the universe reminding us that absence does not mean stillness. The vacuum teems with what physicists call zero-point energy, the faint residue that remains even when everything else is removed. It's as if the universe cannot bear to be perfectly quiet, as though silence itself has a heartbeat. This background hum is the same field from which particles gain their mass, the same sea in which light and matter exchange energy. Without it, nothing could exist. Even stillness needs something to rest upon. From this idea, other dreams have grown, speculative, perhaps impossible, but irresistibly curious. Some physicists, like Gunther Scharnhorst, once wondered whether light could travel slightly faster between the Casimir plates than it does through empty space, as if the vacuum itself could be tuned like an instrument. Others, such as Miguel Alcubierre, imagined bending this vacuum to create a bubble of space that moves faster than light, not by breaking physics, but by curving the fabric of reality itself. The idea became known as a warp drive, though it lives more comfortably in the language of dreams than equations. Still, the dream matters. Every scientific leap begins as a whisper of imagination daring to be taken seriously. You can picture these concepts not as engineering projects, but as poetry written in the alphabet of physics, ways of wondering whether the calm between stars hides more possibilities than we can yet see. Because if the vacuum truly trembles, then it holds energy enough to shape the cosmos. Some estimates suggest that even a cubic centimetre of empty space contains more potential energy than all the visible matter in the universe. We cannot use it. We cannot even measure it directly, but its presence may explain why the universe continues to expand faster and faster, why galaxies drift apart as though pushed by invisible hands. This mysterious force is sometimes called dark energy. But that phrase is only a placeholder, a name for something we barely understand. It could be the pressure of the vacuum itself, the quiet insistence of space to stretch and create more of itself. In that sense, the universe's expansion is not a runaway event, but a slow, cosmic sigh, a sign that even the emptiest regions are alive with motion. When you think about it, the idea that the vacuum has energy is strangely comforting. It means that the universe can never truly run out of potential, that beneath every ending lies another beginning. Even when all stars have faded and all matter has decayed, the quantum sea will still ripple, softly, endlessly. Some physicists imagine that, in those far future epochs, new fluctuations might give birth to fresh universes, bubbles rising in the dark ocean of nothing. Others are more cautious, preferring to admit that we simply don't know. But uncertainty too is a kind of beauty. It keeps curiosity awake. The trembling vacuum reminds us that existence is not defined by what is visible. The things we call empty, the space between stars, the silence between words, the pauses between heartbeats, are full of unseen rhythms. In the same way that music depends on rests as much as notes, the universe needs its quiet intervals to make sense. The vacuum is that interval, the infinite rest that gives structure to the cosmic song. If you take a moment to breathe and feel the still air around you, it might be worth remembering that even here, in this quiet, the same invisible fields ripple. Every atom in your body, every photon of light in this room, vibrates in sympathy with that deeper hum. You're not separate from the vacuum. You're part of its rhythm, a fleeting pattern in its endless wave. And so, as we continue our slow drift through this story, we leave behind the macrocosm of galaxies and turn fully toward the invisible, the realm where existence and emptiness blur. For in the trembling of the vacuum lies a question older than time. How can something arise from nothing? And why does the nothing itself refuse to stay still? That is where our next journey will lead, into the quiet miracle of creation, not of stars or planets, but of being itself. The path now carries us deeper still into the moment when silence itself begins to sing. We've drifted through the galaxies and into the trembling vacuum, learning that what we call nothing is full of hidden motion. Now we step into that motion itself, the gentle spark that turns potential into reality, the breath that allows existence to begin again and again. This is the story of how emptiness creates. In the language of quantum physics, the vacuum is never perfectly quiet. It seethes with uncertainty. Tiny pairs of particles and their opposites appear and vanish constantly, borrowing energy from the void and returning it so quickly that nature never notices the debt. They are called virtual particles, though the name feels almost too shy for what they are. Flashes of being, moments of becoming. They exist for such a brief instant that even calling them moments seems extravagant. And yet, their presence is real enough to affect the universe. You can imagine it as a field of grass in a steady breeze. From a distance, it looks calm and uniform. But if you look closely, every blade bends and sways on its own rhythm. The grass never stops moving. It only appears still when seen from far away. The vacuum is like that. Every point of space gently rippling with fluctuations too small for any eye or instrument to see. And out of those ripples, from the hum of nothing, everything we know was once born. In the beginning, long before galaxies, before light, before even time could stretch its wings, the universe may have been one such fluctuation, a quantum event that grew instead of fading. It was not so much an explosion as an unfolding, a small patch of potential expanding faster than comprehension. Physicists call it inflation, but the word hides its strangeness. In less than a heartbeat, that initial, seed of energy expanded from smaller than an atom to larger than a galaxy. The rules of scale ceased to matter. Space itself ballooned outward, smoothing and stretching until the cosmos became vast enough to cool, vast enough to last. From that moment onward, creation became a habit. The fluctuations within the vacuum continued, seeding matter and light wherever conditions allowed. Tiny variations in density became the fingerprints of galaxies. Sound waves rippled through the early plasma like gentle chords through water. As the universe expanded and cooled, the first atoms formed, then the first stars, then the first heavy elements, forged in those stars' hearts and scattered again by their deaths. The cycle of creation and return had begun, not once but forever. Even now, the same principle endures. In every corner of the universe, quantum fluctuations flicker, giving rise to brief sparks of light or energy that appear, interact, and vanish again. On a human scale, we barely notice them. But on cosmic scales, they are the whispers that shaped everything. Without that slight uncertainty, the cosmos would be perfectly uniform, perfectly symmetrical, and perfectly lifeless. It is the randomness, the tiny imperfections in the vacuum's hum that made stars and life possible. There is something profoundly moving in that thought, that the universe was born not from certainty, but from hesitation. Creation began with a fluctuation, a shimmer in the stillness, a question that could not help but answer itself. It suggests that the cosmos is not a cold machine, but something more delicate, a place that thrives on balance between silence and song, between absence and expression. And perhaps this process never truly ended. Some physicists imagine that even now new universes may be budding off from ours, tiny bubbles of space forming within the deep vacuum, expanding into their own realities, invisible to us but real in their own frame. In this picture, our universe is not the only one, just one wave in a vast and endless sea of creation. The thought feels almost too large to hold, but it carries a strange serenity. Infinity, after all, doesn't need to be crowded, it only needs to be fertile. Closer to home, the same dance of emptiness and form unfolds constantly. Inside every atom, the space between the nucleus and its electrons is mostly vacuum, yet that vacuum is alive with energy. Even within your body, in the tiniest gaps between particles, fluctuations stir, infinitesimal echoes of the same creative hum that birthed the cosmos. You are, quite literally, made from the rhythm of the void. The matter that builds you is mostly emptiness, and yet from that emptiness arises thought, feeling, and awareness. It's hard not to feel a little wonder in that. When scientists talk about creation, they often speak in numbers and equations, but there's another way to think about it, one closer to the language of experience. Imagine sitting in a dark room perfectly still. There is no sound, no movement, but as you listen, you begin to sense faint shifts, the soft creak of wood, the gentle vibration of your own breath. The silence, you realize, is not empty at all. It is full of potential, alive with the possibility of sound. The universe was like that, and perhaps it still is. Every act of creation, no matter how small, echoes that original moment. When a seed breaks open beneath the soil, when a thought flickers into awareness, when a star is born from collapsing gas, each is a tiny reenactment of the same principle, something emerging from almost nothing. Creation is not a one-time miracle. It is the natural state of a universe that refuses to stay quiet. And yet, there is peace in that motion. The vacuum does not rage or explode. It hums softly, like the ocean against the shore. It creates by trembling, not by force. The universe does not need permission to be beautiful. It simply unfolds, continuously, from within itself. So when we look at the night sky and feel small, it helps to remember that we are looking at our own reflection. The same uncertainty that shaped galaxies also shaped us. Every atom in our bodies, every thought in our minds, carries within it a trace of that original fluctuation, a soft echo of the moment when nothing decided to become something. And if you listen carefully in the stillness between breaths, you might feel that same pulse, a reminder that creation is not far away, but all around and even within. The hum of existence never really fades, it only changes tone. And as our journey continues, that hum will lead us back toward the places where we've learned to listen best. The telescopes, the instruments, and the human eyes that still search the sky for new surprises waiting in the dark. Our quiet exploration now turns back toward the instruments that let us see, not just with our eyes, but with our shared curiosity. After tracing the universe from the first dawn to the trembling of its vacuum, it's time to return to something beautifully human, our need to look upward and ask what else is there. That question has followed us for as long as we've existed, written in every campfire, every polished stone, every telescope we've ever built. And now, with one golden mirror floating in the cold of deep space, that question has begun to answer itself. The James Webb Space Telescope, often simply called Webb, is humanity's most delicate eye. Launched at the end of 2021, it took its place about 1.5 million kilometers from Earth, at a point of gravitational balance known as L2. There, shielded from the sun by a silvery sail of thin layers, it opened its mirrors like petals, each hexagon unfolding with the precision of a heartbeat. When the final latch clicked into place, a cheer rose from Earth, not just from engineers, but from anyone who had ever wondered what it might feel like to open an eye after 13 billion years of sleep. What Webb sees is not the present, but the past. Its instruments are tuned to infrared light, waves stretched by time and distance until they are too faint for ordinary eyes to see. This light began its journey billions of years ago, when the first galaxies were young, their stars still burning through the leftover hydrogen of creation. By catching that faint warmth, Webb lets us look back almost to the beginning, to the edge of the visible universe. It is, in a sense, a time machine built of gold and curiosity, and the stories it tells have surprised even the people who built it. When Webb's first deep-field image was released, a tiny patch of sky no larger than a grain of sand held at arm's length, it revealed thousands of galaxies, some so distant that their light had been travelling since the universe was less than 400 million years old. We expected to find a few faint smudges, the fragile beginnings of structure. Instead, Webb showed us mature, bright galaxies, already spinning and forming stars at a furious pace. It was as if the universe had hurried to become itself, far faster than our theories allowed. Astronomers are still debating what it means. Perhaps these galaxies are smaller than they appear. Their light magnified by gravitational lensing, the bending of space by massive objects in between. Or perhaps our understanding of how quickly stars can form needs to change. Either way, the lesson is the same. The universe remains more awake than we imagined, more impatient to exist. Webb's gaze hasn't only turned outward to galaxies, it has looked inward too, toward the worlds circling other suns. One of its first triumphs came from studying a planet called WASP 96b, a gas giant roughly 1,000 light-years away. Earlier observations had suggested its atmosphere was clear, almost featureless. But Webb saw otherwise. When the starlight passed through the planet's air, it revealed traces of water vapour, a spectral fingerprint hidden in the faintest shift of light. There were also hints of clouds, possibly made of fine dust or haze. In that small discovery, a wisp of moisture on a world we'll never visit, humanity glimpsed the possibility that water, that patient sculptor of life, may be far more common than we once believed. Webb has also turned its mirrors towards stranger places. In a triple brown dwarf system, 3 failed stars, each too small to ignite fully, it found silicate clouds, tiny particles of sand or glass drifting through their atmospheres. Imagine a sunset over a world that never truly brightens, the air glimmering with powdered glass as faint heat glows from below. It sounds like science fiction, but it's a quiet truth written in infrared light. The telescope doesn't just show us distant things, it shows us how the universe invents new kinds of beauty. Perhaps its most breathtaking images came from the Carina Nebula, a vast region of gas and dust about 7,500 light-years away. In visible light, it was already stunning, a wall of glowing colour. But Webb's infrared eyes peeled back the surface and revealed new stars forming inside, bright embryos still wrapped in their birth clouds, lighting up the surrounding mist. In those pictures, you can almost see time itself at work, sculpting, carving, breathing. Every thread of gas, every shining point is a chapter in the long story that began with the first spark of light. And the surprises continue. Webb has seen galaxies distorted by gravitational lenses, their light curved into rings and arcs by intervening mass. It has captured the most distant active black holes ever observed, their accretion disks already blazing in the young universe. It has measured the chemical makeup of planets that circle red dwarfs, small suns that burn dimly but steadily, perhaps offering stability for billions of years. Everywhere Webb looks, the familiar rules seem to soften, as though the cosmos were gently reminding us, "You never truly knew me." But beyond the data and discovery, there is something quieter about Webb, something deeply human. Every photon it captures, every faint shimmer it decodes, began its journey before our species existed. And yet, somehow, it was destined to end its flight inside our instruments, to be measured by a mind that could understand it. When you see those deep field images, thousands of galaxies shining from a time when the Earth was not yet born, it's hard not to feel a kind of gratitude. We are small, yes, but we're also the universe becoming aware of itself. If the earlier sessions were about distance, this one is about return. A return to wonder, to the realization that curiosity is our most profound instinct. The James Webb Telescope is not just a machine, it's an extension of our collective dream, a mirror held up to the cosmos and to ourselves. It shows us that the universe does not age into silence. It keeps surprising, keeps creating, keeps reflecting light from its own shadow. Perhaps that's the real message of Webb's discoveries, that the universe is more alive, more restless than we ever dared to believe. The same curiosity that drives us to look outward is the same energy that drives the cosmos to create. Each discovery, each image, each gasp of astonishment is another small echo of the moment when emptiness first learned how to become something. As we continue our quiet journey, we turn from the telescope's open eye to our own. The stars are still there, shining in their vast billions, but between them there is a deeper kind of light, one that belongs not to the sky, but to awareness itself. Soon we'll drift into that stillness again, where light fades and thought begins to settle into the silence between stars. The trail of our journey now leads us into the quiet, once more, to the space that lies beyond sight, beyond discovery, beyond even words. After the brilliance of galaxies, the tremble of quantum fields, and the golden eye of our telescopes, the story returns to where it began, to stillness, to the silence between stars. You might imagine that silence as empty, but it isn't. It's the softest fullness there is, the background on which every song of the cosmos is written. Between the stars, in that deep night where light travels for billions of years without meeting another world, the universe rests. Not dead, not finished, just resting. The same way a breath pauses before beginning again. If we could see the whole of existence at once, from the nearest dust motes of our solar system to the farthest edge of what can ever be observed, it would stretch across about 93 billion light-years. A number so vast that even the word billion begins to lose meaning. Light, moving at almost 300,000 kilometers each second, would need 93 billion years to cross from one end to the other. And yet, all of that distance, all that unimaginable size, still fits within the horizon of what we can measure. A kind of cosmic bubble defined not by walls, but by the limits of time itself. Beyond that horizon lies the unseeable. It isn't a boundary in the way a wall ends a room, but rather the edge of a story still being written. Space and time continue beyond it, we think, though we cannot know how far. Perhaps the universe is infinite. Perhaps it curves back on itself like a closed loop, or perhaps it expands into regions forever beyond our reach. Whatever the truth, the edge is not an end. It's simply the furthest place our light has yet to travel, and our imagination keeps going long after the photons stop. The space between stars is a strange kind of comfort. It holds everything, yet demands nothing. It's filled with faint traces of what once was, a few stray atoms drifting in every cubic meter, the ghostly radiation of the first dawn still glowing softly, and our own signals. Tiny ripples of radio waves carrying the voices of our species. Music, news, laughter, whispers, all travelling outward at the speed of light, spreading into the darkness. Long after we're gone, those faint signals will still be moving, expanding through the night. Some of them are already far beyond the reach of our solar system. The earliest television broadcasts, the first coded beeps of satellites, the words of greetings recorded on the Voyager probes, all have crossed into interstellar space. They are now drifting toward the nearest stars, though it will take tens of thousands of years for them even to arrive. Imagine that. Fragments of us, tiny sparks of curiosity and noise, travelling forever through silence. In a way, they are our descendants too, not made of flesh or thought, but of intention. It's here, in this scale of quiet, that people sometimes ask the largest questions. Is our universe the only one? Are there other realms where time flows differently, or where the constants of nature take on new values? Theorists speak of a multiverse, countless universes, each bubbling like foam in a greater sea of space-time. Some may be small and short-lived, others vast and slow, all born from the same trembling vacuum we spoke of earlier. If this is true, our universe may be one breath among infinite others. But even if it isn't, even if this is the only one, it is more than enough. Its beauty lies not in how many copies exist, but in the quiet perfection of the one we can see. Others wonder if our reality could itself be something imagined, not by gods or myths, but by information. The idea is not as fanciful as it sounds. Some physicists describe the universe as a vast computation, a pattern of energy and logic playing out across cosmic time. In that view, everything, stars, atoms, memories, even this thought, would be part of an unfolding code. But even then, the mystery doesn't diminish, it deepens. For if the cosmos is a simulation, who or what is doing the dreaming? Perhaps existence itself is both the dream and the dreamer. It's easy, when faced with such vastness, to feel small. But smallness can be beautiful too. If the universe is infinite, then the smallest consciousness within it still completes it. You are part of the equation, part of the pattern. Every glance upward, every quiet question, adds to the light. The same curiosity that built telescopes and equations is itself an echo of the cosmos learning to see. When you wonder about the stars, it's not just you looking at them. It's the universe looking back at itself for a moment through your eyes. Somewhere, right now, light from a distant galaxy that began its journey billions of years ago is brushing past you, passing through your skin and the air you breathe. You can't feel it, but it's there. A soft rain of ancient photons falling everywhere at once. The same glow that warmed the newborn universe still touches you, still hums around you. Even in this moment, you're surrounded by the memory of creation. And so, we return to the silence between stars, not as an absence, but as a promise. Silence is the universe at rest, the pause before the next note in an endless song. Perhaps one day, new stars will be born where the old ones have faded, and light will find its way again through the dark. Or perhaps the cosmos will cool into stillness, its last embers flickering out as space expands forever. But even then, the energy of those first moments, the trembling vacuum, the spark of creation will remain, written into the very geometry of existence. If you listen closely enough, the silence is not empty. It is full of echoes, the hum of radiation, the slow breathing of galaxies, the faint traces of our own signals fading gently into infinity. The universe does not forget. Every atom remembers. Every vibration continues, softer and softer, until it becomes indistinguishable from stillness itself. And here, at the end of our long journey, that stillness feels like home. We began with curiosity, drifted through distance and time, and arrived where everything began. Not in chaos, but in calm. The same calm that fills the space between stars now fills you. It invites rest, reflection, and the quiet recognition that being small does not mean being insignificant. Because in the vast silence, even the smallest whisper matters. Every thought, every kindness, every wonder is a thread in the great fabric of existence. And though the stars are far away, their light still reaches you, just as yours, in some way, reaches them. So, as we close our eyes and let the night unfold, remember this: the emptiness of the universe is not a void to fear, but a place to belong. It is the quiet echo of being itself, a lullaby written in light and time, and with that our journey through the cosmos comes gently to rest. Whether your eyes are still open or already half dreaming, thank you for wandering through the stars tonight. May the silence between them cradle your thoughts, and may you drift into sleep wrapped in the soft hum of infinity.